Hello, everyone. Thank you so much for joining us today for the JanusGraph Meetup. I hope you are excited as we are. We've been looking forward to this for quite some time. Just so you know, before we get started, that we will have time for Q&A at the end of each session, and you can submit your questions in the Q&A box at the bottom of your screen at any point during the session, and we'll get to as many of those after each speaker as we can. This meetup is being recorded, and you will get sent the recording as well as all of the presentations once this is finished. And my name is Ashley Hill. If you have any specific questions about how things work or any general questions, you can send those to me directly in the chat. So just want to say good morning or good afternoon, depending on where you're located. I know our speakers are located all over the world today, so we're in a couple of different time zones. But without further ado, I will hand it over to our first speaker, Chris Hupman. He's going to be talking about the state of JanusGraph 2019.
Hello, my name is Chris Hupman. I'm a contributor on JanusGraph, and I'm a systems engineer at IBM. All right, so to get started, first thing I want to kind of do is go over the milestones we had for each, I guess, major release, as we're going to call them. So 010 and 011 were basically, those were when Titan was forked over and became JanusGraph. And so the major things that went in there, I would actually say backwards compatibility with Titan was probably the biggest, most important thing that happened. Google Cloud Table was, our big table was added as a backend through HBase, and some query optimizations happened as well. And then for developers, I think the nicest feature that happened was the CLA checks. So anytime someone goes to make a contribution, automatically we know whether or not we can merge that in. I think Misha Brookman actually wrote that bot for us, who's one of the steering committee members. And then in the 0.2x release, the major thing that I think went in was configured graph factory. And that allowed you to have more than a single graph on a Gremlin server instance, which is very handy. I know coming from different database systems like MySQL or Postgres, it'd be very weird if you could only host a single key space or a single database on your server. So with Configure Graph Factory, that is no longer the case. Now we can have multiple graphs on a single server hosting, which is great. The Google Cloud Bigtable module actually became a standard module, no longer just through HBase. The CQL backend was added, and when I went through the issues and the pull requests that went in, there was a ton of documentation improvements that went into the 020 and 021 releases. I think there was like 230 something like tagged releases between the two of them. So that was a very large release. For the devs, we first started using Travis CI, and coverage scans went in, which does some static analysis for us, so we can find security vulnerabilities, null pointer exceptions. Helps us basically improve the software, and looks over the whole code base. Makes it very nice for us. And then more recently, the 030 releases and 031 releases came out. The major thing that changed there was schema restrictions were added to JanusGraph. So now you can actually say, these properties have to exist when I add things in, and it's very nice to have those in there. And if you have questions about that, one of your other speakers will be able to answer that much better than I can, since he's the one that wrote them. Dynamic bindings for traversals in configured graph factory. That was another major feature that came out. So if you were using a Gremlin language variant or some other plugin to work with JanusGraph, like an existing server, there wasn't really a great way to initialize your traversals. Now when you add a graph on Configure Graph Factory, the name of that graph will be automatically added as a traversal that you can access with just the name of the graph _ traversal. So you don't have to do that extra setup step. So that's really nice. Tinkerpop 3.3 was added, and for devs, very recently we added Codacity, which does pull request static analysis for us, which has been a blessing and a curse. There were some complaints about the number of emails that it sends to people, which I experienced for the first time this morning when I woke up with like 80 emails, and I think 70 of them were Codacity. And then DCO verification. So a developer certificate of origin should be on all commits that go in. And so that's something that's very tedious to check. That was very nice to have that added, so that we're able to not have to worry about those kind of things and make sure our code base is being maintained properly. So the things people should care most about is what's coming up next. So we just added the 0.4.0 or the 0.4 branch, and the main things I found that are currently in the works, and they're either already merged or very mature pull requests. Multi-query is being undeprecated. So that was something that was deprecated back when the code base was still Titan. They probably had plans to replace it with something else. Those plans never came to fruition. And so it makes sense to undeprecate that so people can use it going forward, not having to fear that it's going to go away. For accessing schema, there was a lot of commands required to find out, basic information. So Robert Dale actually wrote this really cool script that would give all the information for your schema. And so what I did is I basically took that and I made it into built-in API commands. So in the new releases, I think that's actually going to be in 0.3.2 as well. But since it's not out, I put it in the 0.4 branch. You'll be able to just do, graphed up, or once you access the management, you can do management.print schema, and you'll be able to see your indexes, what property keys are being indexed. A lot of information that would take like 6 or 7 different commands and a lot of typing to get before. Tinkerpop 3.4 will be going in, and our documentation system, there's a PRN to basically overall how it looks and interacts, and I took some screenshots of that I will be showing later on. For developers, the main thing that I'm looking forward to is we'll be dropping end-of-life backends, so like Elasticsearch versions 1 and 2, and some really old versions of HBase, which will be nice because we currently do testing for those, and once they are removed, our test suite will run much faster. License headers for files, that was automated, and the check was automated, I believe, by Mr. Florian. And JUnit 5 was added. So we upgraded basically, how we run tests now to JUnit 5 from JUnit 4. It makes it a lot more flexible for us. And sorry, any question there. It makes it a lot easier for us to deal with the massive inheritance chains that come from Java, to write tests and have it be more flexible. And test containers, I think, may go in that release. So there's some PRs in that, but that one is a big piece of work. So I think we'll have to see on that one if it makes it in the next release, but that's just for developers. Okay, so who contributes to JanusGraph? This I basically pulled manually. I went through all the contributors, and I decided to say, I just kind of did a hover over, and if they had a country listed on their profile, I made that blue. And so there were 61 different contributors for just JanusGraph proper. Before, we have the Titan code base brought in, so I only grabbed the stuff from after the fork. So we have 16 different countries from people developing and 61 separate contributors, which I thought was kind of cool. All right. So from some organizational stuff that's changed this year, we are very happy to have a new TSC member, Florian Hupman. He's done a lot of great work. He wrote the .NET plugin that we'll be talking about in a little bit. Very active in pull requests and discussions, and huge blessing. Also, on the Tinkerpop steering committee, I believe. And then Jansen, who will be speaking later, and Alexander Poranov were added as committers. Also incredibly active, done some great work cleaning up testing, adding test coverage. They've added some new features. Jansen did, I always want to call him Faradin because that's his GitHub name. But he added schema constraints, the JUnit 5 upgrade he did. Alexander helped with the review on that, which was great. And for this year, we so far have commits from 8 different contributors. And the cool thing is 4 of those were first-time contributors, which is a great sign that the community is still growing and new people are adding in. So that was made me very happy to see that. Okay. So last year, in the last 6 months, we added 4 different repositories. And let's see, I did them in alphabetical order, not order of importance by any means. So JanusGraph and Bari, it is a plugin to install JanusGraph on Apache Ambari or Hortonworks data platform on versions 2.4 through 2.6. 2.7 made some breaking changes, so it will not work with that currently. It was just another way to basically make JanusGraph consumable. JanusGraph Docker, which is a very cool one that I'm excited about. It has it's the repository for our official images. And let's see, it's I think right now we have 0.2.0 and 0.3.0 in there. But going forward, that's where we'll have an official JanusGraph Docker image, which will be great. So hopefully we can start doing, suggestions on how to do, Kubernetes pods with Elasticsearch and with Cassandra and some other backends too as well, just to make it easier to consume. So that, it's a Docker image, so it's self-explanatory, but I'm very excited about, what it means for how easy it's going to be used in JanusGraph in the future. JanusGraph.net and the JanusGraph Python language drivers were also added. These are a huge piece for consuming in different applications that are not Java. So they add the ability to use JanusGraph predicates like text and geo. I have a whole slide dedicated to these, so I'm not going to stay here too long on this, but JanusGraph.net, actually the initial PR just merged last week, and JanusGraph Python, I think we have a lot of activity on it, and I think it should be hitting its initial PR going in soon. And then hopefully in the near future, we'll have those released. But those should be coming very, very soon. Okay, so why do language drivers matter? Gremlin and Tinkerpop already have Gremlin language variants, and those only allow you to access the Tinkerpop functionality. So we needed a way to add things that are in JanusGraph so you can actually access them from, currently .NET and Python. Maybe someday in the future we'll have JavaScript as well and other languages, but being able to interact with mixed indexes is huge. That's a huge part of the functionality that I think that makes JanusGraph, so powerful. So text predicate operations can now happen. So things like doing regex searches, partial matches. Instead of for composite indexes, you have to do exact matches for any kind of search. Like I've done this to make an API for type ahead. I did a demo application for with some airport data, and so you could basically say, I want to go from SFO to JFK with this many hops. Show me this many routes. And now that I have the geo predicates available to me, I can also say, show me the 3 closest airports within those. And so I have a coordinate point, and I can just draw, a circle, and it shows me all of the other airports that show up within that circle. And that's something that I couldn't do with just the GLVs. So it's we now have access to we will eventually have access to the full depth of JanusGraph and what it offers. And in the future, if new features come out, we'll actually have a place, to enable people to use those. We can add them in some place. We have an avenue for that now. So going forward, that's going to be huge for development and usability. Let's see. Oops. Okay, so I think next I have a preview of the new documentation system. So I should have included a picture of the old docs, but if you're on this call, you've probably seen them. So here's the new look. And as you can see, it's very clean looking. You can see the GitHub stars. Most of it's pretty similar from just a normal appearance of what we have, but major things are now you can actually search. Before, if you wanted to search the JanusGraph documentation, you would go into Google and type JanusGraph and whatever you're looking for, and you hope you got the result you wanted. So that's going to be a huge improvement just for finding things. And then also for navigation, it now has, you can click on this little menu here, and it'll show you everything. Before, you had to go back to the initial page to find everything, which was not great. I think also the only thing we're missing is switching between versions, and then hopefully this can go in, because I think it's a big improvement, and it'll make life a lot easier for new users. And since it's Markdown instead of our current system, it'll be a lot easier for people to maintain. So I think that is just that. I talked faster than I meant to, so I'm a couple minutes before. Hopefully I can get some more questions. But my name is Chris Hupman, once again, and I'm pretty active on LinkedIn. I have like 5 posts on Twitter and like almost no followers. So, I will try to be more active this year, but it's not really my favorite social media outlet. I'm very active on GitHub, and, most of the stuff I do there is JanusGraph related. I also did a 3-part series, which was supposed to be a 4-part series, and hopefully will be this year, but about getting started with JanusGraph, where I did a deployment with, taking some GraphML airport data, put that in, add indexes, do some traversals, and some basic, added some basic, administrative options on, how you interact with it. And I think I did like a backup of the Docker images, since doing Cassandra backups was too complicated for a blog post. So I am going to then, I think that is it for me. And hopefully people have some questions.
Awesome. Thank you so much, Chris. You definitely did get some questions. And just before we start to answer those, for those of you who have joined since we started, just want to let you know you can send questions either in the chat or in the Q&A box at the bottom of your screen. Or if you have any direct questions about how this works or anything like that, my name is Ashley Hill, and you can send me a direct message. This will be recorded and sent out. That's a common question that we get from people. So to start out, we did get a couple of questions, and I'm not sure if you answered these as you went along because they were coming in as you were speaking, but I'm going to go ahead and just read them off to you anyway. The first one is it possible to start and stop JanusGraph CQL as a Windows service?
I actually do not use Windows for JanusGraph. So let me see. There's a bat file, and I would have to look to see if it has start and stop. So I am working on doing a start stop for the Gremlin server that comes with JanusGraph. I have a pull request in for that, so you'll be able to do that on Unix systems. But unless you're doing the JanusGraph.sh, I'll have to check on that. I think I don't know how to do it. I'm sure you could write a wrapper to it. I don't know if it's natively there though. Sorry.
Yeah, no worries. And our other panelists are welcome to chime in if you do use Windows.
Yeah, I haven't actually used Janus with Windows, but I think there'd be a little bit of work on your side to do that, but I think you could make that work. Also, if you do get that working, it may be of interest to other folks, so we would definitely appreciate a pull request for that.
Awesome. Another question we have here is, Rado says, I remember a few months ago, it was pretty difficult to find a proper version of Hadoop working with JanusGraph. Will that be easier in upcoming releases, and is there any documentation?
Let's see. I wish Jerry was on the call. Actually, he was doing a lot of work with the tube stuff. I think, and hopefully someone else can chime in on this. I think support for Hadoop 2 is coming out, or HBase 2 is coming out. I usually work more on the Cassandra Elasticsearch side, so I don't know a ton about that. If you use Embari, you can just use the plugin, and that should take care of installing it for you there. But I have seen work for more support, and I believe it should become easier. And I'm not aware of any specific documentation on that. But
someone from one of our attendees wrote into the chat. Chris, I don't know if you can see that.
okay, the open one. So what I see, it's a recommended approach to talk to Janus, not using Gremlin, using Java language. Okay, so yeah, you definitely, using the Gremlin console, still a great way to interact with JanusGraph. And writing Java applications is still like it's the first class citizen for interacting with JanusGraph. I would like it to be where you could use JanusGraph without being a Java developer. Maybe you work in Python, you work in JavaScript, you work in .NET, and you can still use JanusGraph. It should just be a database that you make connections to. So those are still probably the best ways to work with JanusGraph. But I think it's important that we add, additional functionality so people using other languages can still get their work done. So yeah, if you're a Java developer, JanusGraph is still very much so great for you. And if you use the CLI is not going away, and it's still how you get most of your stuff done day to day. Hopefully that answers that question. Let's see.
Yeah, and I guess just to be clear, looking at that question, like in all, like what Chris showed with Python and .NET, and then even the Java piece, like you're writing Gremlin for all of these still. It's more of just what language is that Gremlin kind of embedded in. So the supported approach is to write Gremlin. It's just previously we didn't have support for some of the JanusGraph specific features for the non-Java drivers.
Well, and for the question before this most recent one, one of our attendees chimed in on the chat and said, I have the answer for this question. We are using HBase 2. Any plans for Janus cluster for HA?
I haven't seen any.
For the Hadoop question.
I haven't seen any pull requests specifically on that. Or actually, I don't even know of any specific issues asking for that. So if you have something in mind, definitely feel free to open up an issue, documenting what you think needs to be in there. We do look at those. I did a full sweep through all of them, and just to do a massive cleanup, and closed a bunch of things that probably should have been like a mailing list question. So yeah, if there's a feature you want to see, definitely add an issue. But I'm not aware of anything in the works currently on that. So
cool. Great. So the next question says, can we restrict properties to be not null in JanusGraph?
I believe that is the case, but I'm hoping I can get Jan to chime in here. If he's not awake, because he doesn't speak till much later. But I do believe that is one of the things you can restrict with schema restrictions. I haven't worked with them extensively. I do mostly just demo applications. And one thing to know is you do actually take a performance hit adding in schema restrictions, because you have to do additional checks. But yeah, I believe you can, one of the things you can do is check things to be not null. So.
Cool. And Jan, I don't know if you had any other feedback for this question, or if you're on.
Yeah, to the restrict, there are two different parts of being null. Object value can be null, or the property doesn't exist. It's two different things. So what do you mean?
So if we add we add something and we add a null value, can we restrict that from going in?
I don't think so. In the other case also, but I'm not sure 100% in this. So the other case, you can't ensure that the property must exist, but the other thing I'm not sure 100%.
Okay. Yeah, there was talk about it enhancing schema restrictions too, but I think that's going to be further down the line. But yeah, I okay, maybe I take a step back. So yes, if you can validate that the property is added, but I don't know if you can actually validate what it contains. That would have to be consulted the documentation on that, which actually now that I'm not sharing, I can go do that. But so I'll come back to that one.
Cool. Cool. So I'm going to go ahead and move on for now. Jagadesh says, looking for a clustered environment. Not sure if that's a question or if you can have anything to say about clustered environments with JanusGraph.
Okay, so most of the clustering happens on your backend. So your Cassandra HBase, Elasticsearch. If you want to run multiple JanusGraph servers, those just both communicate with the backend, and normally you would throw a load balancer in front of them. So you can run multiple JanusGraph or Gremlin server instances, but as far as there's not like real clustering, you just add multiple instances, and then you throw a load balancer in front of them to handle. And then you probably want to make sure people get the same instance each time, and then you could have multiple users hitting it or multiple services hitting it. But yeah, it's not like there's no real clustering going on there. It's just the backend's clustered and you're accessing it, and you can add more clients to get more throughput.
Cool. What is the most common storage backend to use with JanusGraph?
I feel like Cassandra is the most common with Elasticsearch, but I mean, we get a ton of questions for HBase and Solr as well. So I think most people use either one of those two combinations. But I do think I see probably more questions for Cassandra and Elasticsearch than I do for HBase. So just based off the mailing list, that I would answer that, but I wouldn't say it's that huge of a difference.
Okay. One of our attendees says, thanks for the great overview, Chris. Are there any plans to introduce a language variant for Golang? Does this depend on Tinkerpop introducing a Golang variant first, or could this be potentially independent?
A current model, I would say, is we would probably wait for there to be a Tinkerpop Golang variant, and then we would just extend it. That's how the .NET and the other ones work, and the Python one works. So yeah, I mean, I guess it could potentially be independent, but I think it would make sense to upstream the Tinkerpop stuff to make one first, and then extend it for the JanusGraph specific implementation details. So, I mean, it could be independent, but I think it would be more appropriate to first create the GLV and then extend it.
Okay. How different is JanusGraph from TitanDB? Does Janus have anything similar to Titan server, which internally helps with load balancing?
So I actually didn't interact much with Titan. I came in when JanusGraph was 0.20. So it's a fork of Titan. So it's very, very similar. Like I said, we've just added a few features since then and been maintaining it going forward. Internally helps load balancing. I'm not aware of anything particular. If anyone else wants to hop in, I mean, Ted was the first one to do. He was the release manager on the O&O. Maybe he knows.
So Titan. I guess I'm not quite certain with they're referring to with the load balancing piece. But yeah, as I was a Titan user for probably about 3 years before Janus came around, and yeah, really, I mean, like Chris said, JanusGraph is really, it's an extension of Titan. Fundamentally, the data model, the storage model, is still the same as it was in Titan, and so it's really just a continuation of it. So I would get, I'm not 100% sure what the load balancing is being referred to, but I would venture to guess it's the same as it was in Titan. Oh, I see. Okay. Yeah. So yeah, the data stacks, so the driver usage and the communication with Cassandra, yes, still has that capability, like Titan could, to load balance across the Cassandra servers using the smarts of the driver. So.
Cool. We have time for a couple more. Any plans to provide a backfill tool for JanusGraph?
I'm not a Neo user, so I actually I don't really feel qualified to answer that one. I'm not aware of anything like that. Ooh, can I maybe skip a couple and answer Alex's question, since that's really my week? So question is, have you talked with Misha and people from Linux Foundation about CLA automation? Is there any news? So Misha and I had a call about the Linux Foundation is working on a project to automate CLA signing, where you could do like DocuSign. And basically, it looked good. And I think the takeaway was, when that goes GA, we will want to use it. So whenever the Linux Foundation finishes that project, I think we will probably have a change to our CLA signing. There'll still be a corporate CLA and individual CLA, but I think people will no longer have to print it out, sign it manually, scan it in, and email it to us, and they'll build a DocuSign, which I feel is a huge improvement.
Hey, this is John Mertic. I'm speaking later, but I can say for a fact that system is coming very, very, very soon. I think we have a few projects that are in beta with it. So if you need help getting engaged, let me know.
Cool. I mean, yeah, it looked great. I'm very excited about it. So.
Awesome. I'm going to do a couple of questions that were in the chat rather than the Q&A. Are the trainings presentations you made on JanusGraph on deployment usage available online?
Yes, they are. I believe the link works in my slides, although I did update my slides, so I'll send a new version of those to Ashley. Yeah, so it's I think if you Google getting started with JanusGraph, it'll be like one of the top ones there. But it's on it's called DW blog. It's a developer works blog that I wrote there. So, and I think you can also find it in the user group, JanusGraph users. I posted links there as well. So
awesome. And then another one says, GQL as a new standard graph query language is being designed. Is there any plan to support GQL on top of JanusGraph in the near future?
I am unaware of anyone working on that at this point. So there's no PRs, and I haven't seen anything in the dev list on that.
How is JanusGraph different from AWS Neptune? What are the benefits?
I mean, I haven't played much with Neptune. I would say the benefits of Neptune are it's a cloud service that you can just load up. I mostly work with JanusGraph on Compose. So we have a native hosting of JanusGraph on IBM Cloud. So that's usually what I work with instead. But you know, one of the people that worked on Neptune was also a JanusGraph contributor. So I'm sure it's got good stuff too. I haven't really played with it though. So I spend most of my time on JanusGraph.
Cool. Chris, I'm going to let you look through the rest of the questions and see if there are any that you do want to answer. live. Otherwise, while our next speaker is going, you can type your answers out to people who are in the Q&A box.
Great. Sorry, I went over.
Hey, no worries. We've got lots of great questions here. So do you see anything else you want to answer live?
No, but I'll take a look. I'll be around for the next like 30 minutes or so, and I'll try to answer as many questions as I can.
Cool. And whatever ones that aren't answered, either via text or live right now, if we have time at the end, we'll go over them. If they're still not answered, then we'll do our best to get those answers out to you afterwards. Okay, awesome. Thank you so much, Chris. So now we have our next presenter up, Ryan Stauffer. He will be talking about creating expressive graph data models with JanusGraph.
Hey, thanks, Ashley. Can everyone hear me okay?
Yep, we can hear you.
Perfect. Yeah, so kind of as a follow-up to the state of JanusGraph, I'm going to talk about one of the ways of actually using this to actually develop a data model and hopefully accomplish something useful with JanusGraph. And so it'll be reasonably technical. Definitely feel free to ask some specific questions, and we'll try to answer those at the end. But really what I'm going to focus on is the idea that if we have a graph data system, the key advantage of it is to have a lot of flexibility with the way we describe our data. And the point of that flexibility is that we can create models that really express the true nature of the underlying data. We inherently have these relationships, and we explicitly define them in the graph, and that can be a really exciting thing. Feel free, if you'd like to follow along with some of the code I'm going to show. I have a link right there. And then some of what I'm going to talk about is also based on a Medium article I wrote a little bit ago. There's also a link, and then I think this deck will be hosted by Xfero, so feel free to download this and refer back to it later if it's helpful to you. So just a little bit about me. I'm the founder and CEO of Enharmonic. My name is Ryan Stauffer, and big picture, I like systems that are pretty intelligent, that do things pretty automatically, that don't require a ton of work on the development or the ops side to keep them running. Previously, I did some work with data strategy and analytics for a large private equity-backed automotive company. And then, kind of in a past life, did some work in investment banking and served in the US Army. Now, what Enharmonic is, we're basically a small, hopefully quickly growing Bay Area startup. We're really trying to help companies unlock value through the power of graph technology. And we're really doing that through a couple ways. One is implementation. For example, working on an implementation project with a big Bay Area cybersecurity company right now. But we're also trying to build products that really make interaction with the graph and data in general just very intuitive. And so I think if we take graph and we layer onto that, the power of some of these AI machine learning algorithms, we really can deliver pretty awesome insights. And that's what we're trying to fundamentally do. So any sort of modeling exercise has to begin with data. And so my goal is to use data that's a little bit different than what people may have seen before. And so, we're going to look at a data set of concert performances by US symphony orchestras. It was compiled by the Baltimore Symphony Orchestra. You can definitely investigate this in a lot more detail. But basically, what we're looking at is data where each record corresponds to a single piece or a song performed at a single concert, and then we have a lot of information on the performers themselves. And so in the sample record, we see that we have an orchestra, the Chicago Symphony Orchestra, and they played a concert, and the concert was titled Salonen and Yo-Yo Ma, who are two famous top performing musicians today. We have a date of the first concert of the series. Now that some of this data is imperfect, and actually some of these things are what we're going to deal with in the data modeling exercise. But basically, they've grouped together multiple individual performances into a single record. And the record really corresponds to this piece level right here, which is the idea that we have a piece called Cello Concerto, and it was performed on this concert. And so we can imagine that we may have other records associated with the same concert as well. And so the big question is, how are we going to organize this data so that we can ask really interesting questions? What composers have conducted their own works, like we see here. So S.P. Salonen wrote this, and he also conducted the piece in this performance. Now, when we take the first pass at data modeling, iteration's a really good thing to do. It's unlikely we're going to get a perfect data model the first time around, but we really want to focus on breaking everything down into distinct logical categories. And so, for instance, like we discussed, this record of data has a concert listed in it, and that concert has a title. And so we can think of that as being a distinct entity. We also have a piece, and we have multiple pieces associated with a single concert. So that must be a distinct entity as well. Next, we have groups of performers. And so we have a group of a ton of people playing together, and that's an orchestra. And then we have 3 types of individual artists. We have a composer, we have a conductor, and then we have a soloist, the great Yo-Yo Ma. So I think there's a few improvements we can do over that first pass, though. I mean, our ultimate goal is that we want to have labels that match up a single physical, real-world, logical entity with exactly one element in the graph. And so if we looked at what we did previously, we saw that the same person, Esa-Pekka Salonen, is both the conductor and the composer in this record. So I think it would actually be a little weird if we have 2 separate entities in our graph associated with that same human, because that's going to lead to probably diverging answers depending on the types of questions we ask of our data set. And so maybe we can just roll up conductor, composer, and soloist into a single artist vertex. And then to actually make those functional distinctions, we can just use the edges. So the other thought is maybe we can be a little more generic. And so I use the word piece, which is the idea of a single thing that someone in history wrote, like a symphony or a concerto. But maybe we're not just trying to have classical music in this. Maybe I also want to have popular songs. I want to have a Beatles song, or I want to have a jazz improvisation. So maybe we can be a little more generic and just call our vertex work, which is something that someone created. So that leaves us with 4 vertex labels: concert, work, orchestra, and artist. And now let's go through how we're actually going to build that stuff into a single data model. So to do that, I'm actually going to use this nice little app my company's been putting together. Oh, I think you may have lost my screen. I apologize. That should be back.
Yeah.
So perfect. We're going to use this schema builder and actually interactively build the data model we'd like to put into the graph. And so we'll just start by creating our vertices. So the first one we had was a concert. Zoom in to make sure everyone can see a little bit. And then we had a work. And then we have our performer groups. So we have an orchestra. And then we have an artist. Perfect. So now the question becomes, how are we going to relate these 4 vertex labels? Well, we might say that a concert includes multiple works. We have a many-to-one relationship of works to concerts. So let's just go ahead and create an edge called includes between concert and work. We also have generally we have a single orchestra associated with a concert. And so let's just be super simple and straightforward and not to play too many games with this, and just call the edge between orchestra and concert orchestra. It should be very straightforward as what we're talking about. Another question is, how do we associate the work with the artist? Well, we have a few different pieces we can do. And so one is composer. These are those functional edges I mentioned before. So we're stating that an artist is the composer of a given work. But if we go back to that initial record, we also see that we have a conductor and a soloist associated with each work. So we'll add those edges as well. So we have a conductor and we have a soloist. And so this is basically our data model. Now there's a few different ways of applying to this graph. What I'm going to do is actually show you the very down and dirty version of actually writing management API transactions, which day to day is kind of how a lot of the nuts and bolts of this has to still work. And so what we defined, here's just another view of the exact same thing. We have a concert connected to both an orchestra and a work, and then the works themselves are associated with different artists who provide different functions. So now how do we go about actually defining that data model in JanusGraph? So there's a few different ways of approaching that problem, but it's definitely important that whatever approach we take, we have a good plan. So the plan we're going to use is in 5 parts. We're going to first define all the vertex labels. Then we're going to define the vertex properties and attach them to their corresponding labels. We'll follow on by defining the edge labels and properties. Then we'll go ahead and create the connections between the edges and the vertex labels. And finally, and I specify this specifically, we have to commit the transaction or else you lose a lot of the work we already did. So the best way for these kind of POC examples, or anytime you're just kind of investigating data, working on the data model, it can be really easy to just get up and running with the Gremlin console and providing just an inline configuration. That will let you quickly, as we'll see, ask some questions, figure out if we're getting the answers back we'd like, and then iterate pretty quickly. So basically, we start the Gremlin console, provide that inline configuration. In this case, we're just doing it with an in-memory storage backend. And then finally, we're going to open up that JanusGraph management API. Going forward now, we're going to assume all the code we're entering is just happening within the Gremlin console. So I'm just going to leave out that nice little Gremlin prompt, hopefully make things a little readable. And once again, all this code is on that GitHub gist that I linked to at the beginning. And so, feel free to download that, play around with it, and then shoot me any questions you may have later. So we'll start by defining these vertex labels. And so, for instance, we want to make a vertex label called orchestra. So we'll call that method, we'll make it, and then we're going to assign that to a variable so we can use it a little bit later. We'll do that with all 4 vertices. So next, we're going to define those vertex properties, and using that nice little vertex label variable we had, we're going to attach these vertex properties to that label. So we can start out by making a property key, in this case, title. We assign to it a data type and a cardinality, and then we make it and assign those 2 variables. And then finally, once we've created all the properties we need for a given vertex, we go ahead and call the add properties method. And in this case, we're assigning title, composition date, and solo instrument to the work vertex. Now there's a lot more code to do this completely. So once again, feel free to reference back to that link code for the complete example. Now, once we have that done, we'll go ahead and define the edge labels and the properties. The reason we do the edges after the vertices is generally we need the vertices to connect with an edge. So it makes sense to do the vertices first. So we'll do a similar pattern. We make an edge label, in this case up top called composer. We assign to it a multiplicity. So in this case, many to 1. The composer has many works they've written. And then we're going to make that and assign it to a variable. In this case, we actually don't have any edge properties, which makes some of this a little easier. And then finally, we're going to create these connections between the edge and vertex labels. And so in succession, we just go ahead and call the add connection method. And we're going to add the connection from an edge label, from an out vertex to an in vertex. And then once again, at the very end of all this, you need to commit that transaction so everything sticks. So we've gone about defining a data model in JanusGraph. We're ready to now insert data into the graph to actually check out the model's effectiveness. And so we're going to pretend like we loaded data that fits this model. And so we loaded up a concert, which was titled Salonen and Yo-Yo Ma. It was performed by the Chicago Symphony Orchestra. It includes, in this case, a single work called Cello Concerto. The work was conducted by Esa-Pekka Salonen. He also happens to be the composer. And then the soloist, who in this case is performing on the cello, is Yo-Yo Ma. So now we can ask, a quick little traversal, who conducted Esa-Pekka Salonen's works? If you're familiar with Gremlin, this probably looks pretty straightforward. Feel free to once again shoot any specific questions about why I'm structuring the traversal in a certain way, and I'm more than happy to go into the details of that. But basically, we can see that, hey, we have an artist who is the composer of a cello concerto, of a piece called Cello Concerto, and that same piece was conducted by, in this case, himself. If we had other performances of the same work, we might see other names there. So we see that this is, sort of effective, but there's some issues actually. So when did he conduct this? And that's really unclear because actually the work does not have any dates attached to it. And then which orchestra was performing there? We'll see in a second, it's not really possible that you actually link that given our existing data model. And so fundamentally, that's because we created a work and we directly connected that to only the artist. And so just as we described before, we have a composer and a conductor relationship to one artist, and we have a soloist relationship to another. But say we want to add another concert that featured that same piece of music. So in this case, maybe we have Alan Gilbert in the New York Phil and Alyssa Weilerstein playing cello on another performance. But now we have a situation where we basically have no ability to determine who performed with who. And what that means is that our initial data model was not up to par. It was lossy. We lost some of this core information. And so what did we lose? Well, we lost the idea that a work itself is distinct from the performance of that work. So you might think, that exists with any sort of music. If you have, a band like the Beatles, obviously they made recordings, they wrote songs, but then they also gave multiple performances of those songs. And those are two different concepts. And so to solve that issue, what we need is to actually just define a new performance vertex that kind of serves as an intermediary between the works and the artists. And so that will look something like this, where we have a cello concerto that's been performed a couple different times in this case, and then each performance is associated with the artist specific to that performance. Now, in this case, we still do have Esa-Pekka Salonen as the composer of that cello concerto, because that's tied back to the work itself. That's never going to change depending on who's performing it and when. So if we just go back to that schema builder, we can actually make these changes right here and take a look at what that would be like. So as we said, we need a performance vertex. And what I'm going to do is actually just go ahead and delete these guys, and we'll just pretend like they don't exist and kind of build them from scratch and think through this. So as we described, we don't want the work associated with the conducting and the soloist artist. We want the performance. So we'll go ahead and recreate those here. So we have a soloist edge and a conductor edge between the performance and the artist. Now we do want to describe how is the work connected with the performance. Well, the work was performed during that performance. Perfect. Now we might add a little more detail. We might still want to have the idea that a performance is associated with an orchestra. So we'll replicate that edge. We'll basically assign it to a different set of vertices. And then we're also going to probably have maybe a relationship between the concert and the performance. That will make some of our traversals a little easier. We can once again use an includes edge to accomplish that relationship. And we're left with this data model. And so another view of that is just right here. This is the exact same thing, just shown with some more color coding. And then to actually define that, our goal is to really just define the incremental changes. We're going to go through the same process, but just adding what's different. So once again, we'll start by defining the vertex labels. We'll define the properties and attach them to the labels. We'll define all the edges and their properties. Then we'll create those connections between the edges and vertex labels. And then finally, commit that transaction. So we're going to need a new management API transaction. So we'll open that up. And then we're just going to define this new performance vertex. So we'll make that vertex label. And then we'll go ahead and just assign it a single property key, in this case, performance date. And then we'll attach that performance date vertex, or excuse me, performance date property to the performance vertex label. We only actually need a single new edge label, which is the performed edge label. We'll give it a multiplicity, we'll make that, and we'll assign it to a variable. And luckily, once again, we have no properties, which makes it nice and easy. Then finally, we just want to create the connections between the edge and vertex labels. And so in this case, we do need to actually retrieve the labels we had already previously created. In that case, orchestra, artist, soloist, conductor, because we're not going to be able to actually assign those in different ways unless we have a fresh reference to the underlying vertex and edge label within this current management API transaction. So we'll make these new connections. For example, we're connecting a soloist from a performance to an artist. And then we're going to go ahead and commit all that at the end. So now we have our new schema in place. We still need to deal with the data itself. And so one approach to that would be dropping our data and reinserting it all with some new scripts. That's kind of time consuming and kind of wasteful, especially if we think about having a lot of data in here. We want to be as flexible as possible. And so let's just see if we can do this with data in place. And so we can actually do that with a few quick traversals. I won't walk through exactly what's happening here. Some of these are a little dense, but feel free to shoot me a note. But basically what we want to do is take our given data and create new entities off of it. So in this case, we want to create a single performance for each concert and then connect that performance to the concerts and works as that intermediary like we described. We can follow that by doing the same thing by connecting conductor and soloist artists to the performance. And then we can also remove those artist connections to the works because we don't like that anymore. We realize that was a poor choice we made. Then finally, we'll just connect the orchestra to each individual performance. And so, nice thing about using Gremlin console is we can make these great assert statements that pass or fail depending on if we got everything right. In our case, these will pass. But basically, it allows us to check some nice things like, hey, I just want to make sure I don't have any soloists connected with works anymore. And so I can make a nice little count and assert that I have 0. Perfect. So everything's now complete. This is what our data would look like with this new model. We once again have this concert associated with an orchestra and a work. We have a performance of that work, and we have that tied to the performing artists. So we can actually ask that same question we had earlier, who conducted their own works? And I want the complete performance details on that performance. So if we go down to the bottom here, that's exactly what we do. And the result of that is that we can see that Esa-Pekka Salonen is the composer of a work called Cello Concerto. One performance was on March 9th, 2017. And that performance was conducted by the composer himself, Esa-Pekka Salonen. So we kind of went through a lot there, went through it, reasonably quickly, and I know that was like reasonably dense. But what we did, step by step, was we observed our data, we developed an initial schema. We went ahead and defined that schema in JanusGraph itself so we can use it. We traversed the graph, and then we used logic to identify any shortcomings we saw in our data model. We went ahead and revised the schema we had previously defined in JanusGraph. We modified our data in place. We didn't have to start from scratch or anything. And then we made some quick confirmations to assure us that our new data model does in fact answer the questions we had at the beginning. So, big picture, what we did is we took advantage of this flexibility that we get in Graph that it's really hard to get out of most other data systems. That to me is actually one of the key selling points and usability points for using Graph data system versus relational data warehouse or just using Cassandra, for instance, by itself. Now, obviously, there's still a lot to be done on this, both to evangelize new users and get them using this technology. And there's obviously, some refinement we can still do in the technology itself. So my view is we're kind of all in this together. And if we work hard, we can hashtag abolish table someday. So, let's take some questions. And yeah, thanks for your time.
Awesome. Thank you so much, Ryan. So if you want to follow along with me in the Q&A box, I'm starting with Julian's question. He wants to know, with respect to the data model, is it better to have a lot of vertex types connected by a less number of edges, or to have less vertex types, more generic, and have a lot of different types of edges?
So I think that to that end, it's definitely data dependent. I think there's a few aspects of this. So one aspect is the pure performance you're going to get and the ease of dealing with everything on the kind of the management side. One question is are users, are human users writing traversals off this thing, or is this mainly going to be utilized by some applications, some kind of automated ETL logic? I can say from a current project I'm working on right now, we're over time kind of developing a pretty complex data model, which is great for the people who have a solid understanding of the data. But I can definitely say that, as you run into the 30, 40, 50, vertex labels, that can be, kind of a deep pool to jump into if you're just a new analyst and you want to start exploring this data And it just starts to become a question of like, hey, well, which vertex type am I trying to query for? That being said, like there can definitely be advantages of, splitting things out to their kind of base, lowest form logical entity type. It can make, I think, the indexing a little more straightforward. There are ways to kind of segment those indices out, maybe for a given property key. You can still, have nice performance if you basically restrict indexing of that property key within certain vertex labels, which kind of might play into your answer. I don't know if I answered your question. I apologize. I don't know if there's a definitive answer, but I tried to kind of lay out some of the considerations that you might have.
Awesome. I'm going to go to a few that were in the chat. Does the definition of the schema provide data validation / constraint checking? And what is the best way of converting tabular or relational data to fit the graph model?
So the schema definitely can provide, data type checking, and basically that's, I think, actually goes back to something that Chris mentioned, which is the schema constraints that are part of JanusGraph now. And my view is like in a production system, I think that stuff is just like super important, especially if you're going to have multiple people trying to write to the same graph. So yeah, so for instance, if I try to write to a vertex and I try to write a property that has been defined as being an integer, and I try to write a string to it, that will fail. I'll basically get a response back that that's not allowed. If I try to give it a string when it's supposed to be a date, that will fail. So that can be very nice. In terms of the second part, you're saying how do you convert from like kind of tabular data to, I'm trying to pull up the wording of the question.
Yeah, tabular relational data to fit the graph model. Best way of converting.
Yeah, so that is definitely, I think that comes down to that iterative process where you have to figure out, what aspects of the relational model are we trying to transfer into the graph. My view is definitely your goal should be to make explicit those relationships that you can only develop from these joins when you're looking at a relational data model. And so, for example, if I had to join, for example, customers with a purchase table, that might be something that I'm going to model as, I might develop basically a vertex type of a customer and a vertex label for a purchase. And then as opposed to relying on this join syntax in my SQL query, I'm going to just define an edge between the customer and the purchase and say, purchased. And so in that sense, it can be pretty straightforward. I think there can definitely be different ways of doing that. I don't think you have to be so like slavish in just copying the relational logic you already have, because a lot of times it's rare, I think, in these large kind of well-used production systems that you even have a simple relational model anymore. A lot of these models can be very complicated, and you kind of want to, hopefully get out of that the most valuable kernels of business logic that exist, and hopefully translate that into the graph. You don't just want to make it a repository for like all of the kind of accumulated dirt that's grown in this relational data warehouse.
And if you can see in the chat, he had a follow-up question. Will it also fail for the multiplicity? For example, if I define that an edge is 1-to-1, but then add an edge that is 1-to-many, will it fail?
It will, yes. And that's why, so getting multiplicity right is definitely tricky, and that's why just making sure you kind of have everything right on a small data set is key before you start trying to insert everything in there. Or you may find, down the road, you've done a lot of work, and then you go about trying to insert data for this this edge that only occurs, very rarely, and you may start getting things failing. You have to kind of go back and reevaluate your data model. But yeah, that's once again one of the advantages of those schema constraints that will fail, which is nice.
One more in the chat is, in this model, where are the indexes defined? Are there any downsides of having created indexes versus re-indexing?
So I didn't go over the index creation because I think that is a much broader topic, to be honest. Yes, so I think from my experience, I mean, definitely if you can define the index up front. So for example, there's certain indices that you're just going to need up front if you want to be able to efficiently insert edges, for instance. So if I have, we'll go back to the example I just gave, if you have a customer, I have maybe 1 million customers and I have 10 million purchases. Eventually, as I add that relationship between the customer and the purchase, fundamentally in the back end, I need to be able to look up the created customer vertex and the created purchase vertex. And to do that, I need some sort of key by which to look it up. And so that, unless I want to do these crazy table scans, basically, or a full graph scan, you really need some sort of index in place. And generally, the best way of doing that is, with one of these composite indices, hopefully over something like the equivalent of a primary key. Maybe it's a customer ID or a purchase ID. And so you'll basically, you'll create the index up front before you add data. And then as you insert data, that index will be automatically populated with all of the vertices that you've inserted against it. In that case, that wouldn't generally be an index that you would re-index. One, because it's stored in the primary storage backend, and then two, because that would kind of fundamentally mean you're actually changing this primary key associated with each vertex itself, which is probably not the best idea. In terms of mixed indices, so for example, if we're using something like Elasticsearch, maybe we have an index over the customer name, because we're never going to be looking up customers by a given name to actually create these relationships between them, but we would be looking up customers by customer name to develop a nice user experience on maybe a website. So that is a case where, yeah, so you can create that mixed index on the customer name, for instance, up front, and then it will once again kind of be automatically populated as we insert data. But you could also create that mixed index down the line. Maybe over time you realize that we really need this additional index. Let's go ahead and create it on data that's already been inserted into the graph, and then we'll run a re-index operation over that vertex and then populate that later. There's a few different ways of running that. I think the JanusGraph documentation definitely goes into more details, but basically you can run that. It's kind of an OLAP type job where you can run that basically with JanusGraph itself.
Awesome, thank you. Do you have any plans to make this nice schema creation tool available for others to use?
I do, yeah. So this should be coming out very soon. Definitely be looking forward in the next couple weeks. And, I think initially we'll see kind of how people like it. I mean, from my perspective, it's very useful to be able to, define these data models like nicely and interactively. And then definitely the big goal of this is that everything you do there, I mean, there was a button, I don't know if you saw it, that you can basically apply that immediately to a graph. The idea is that you can not just define it there, but you can also effectively define it immediately in your graph database itself, as opposed to doing what I did, which is walking through the detailed and kind of tedious code that's currently necessary to make a lot of this stuff happen. So yeah, look for that in the next 2 weeks. Feel free to shoot me an email too at the end. And I'll be more than happy to send you a link to it. Or you can check out our website, Enharmonic.ai, and it should be going up there. Yeah, we'll call it the next 2 weeks.
Awesome. In the concert example, was it necessary for the concert vertex to have an edge connected to work, or is that implied by performance? Or am I still thinking too relational?
So yeah, that's where I think it depends on the specific, there's no right answer is the short answer. There's probably like wrong answers, but there's not necessarily a right answer. The answer kind of depends on the types of traversal you'll be running, because right, in theory, you don't need a connection between the concert and the work itself, because right, you can traverse through the performance. And I can, if this is all too like esoteric, I can pull back up that slide. Right, so we can have a concert, and I actually left out the includes performance right here just for some simplicity. But fundamentally, you could have that link between the performance and the concert. Actually, so this is, as I drew it here, I wanted to clean it up. It's technically, once again, a lossy view of the data. If you go back to that data model I defined right here, right, we will have a performance associated with the concert and a performance associated with the work. One advantage of having work associated with the concert is if we're doing concert planning, for instance, and we haven't yet performed this particular concert, but we still want to know what works are going to be performed, you know, in the next 12 months or so. That could be a reason for doing that. So it's very use case dependent. Yeah.
Awesome. Thanks, Ryan. For the sake of time, we're going to move on, but Ryan and the other panelists will continue to answer your questions via text, and we will also send out some contact information for all of our panelists after this is over. Alrighty, so next up we've got Jansen. He'll be talking about a Gremlin DSL for JanusGraph schema management.
Hi, I hope it's working. So,
Hi, Jan,
yeah.
we can see your screen.
Hmm?
We can see your screen.
Oh, perfect. Yeah, we'll think about rethinking the JanusGraph schema management. Currently, you can only do this on the server side, so probably you want as a user. So this is some of the motivation at the start. About me, yeah, Jansen, basic on all platforms. I'm Faradin 91, so I'm working for GData. It's a antivirus software company based in Germany. I'm a committer, as Chris mentioned earlier, on JanusGraph, and currently I'm working on the improving of the documentation and clean up a lot of tests, because it's sometimes hard to know what tests do really did by which part of the code is tested by one test. So that's my part. I'm working on JanusGraph currently. So the agenda will be some motivation why I did these two proof of concept, and both proof of concept, the schema enforcement using a Tinkerpop strategy, and then the proof of concept for accessing the schema with a Gremlin DSL, and then some outlook how to implement these features in future to integrate this into JanusGraph. So the motivation is to reducing the endpoint interfaces. So you probably have the Gremlin consoles, and then the GLV. You can interact with the schema only with the management currently. That's internal graph, but you have to use the special interface, and there are three interfaces to access the graph data. So my idea is to reduce this to one interface, only the Gremlin, probably the Tinkerpot part, and then you can add other language based on the Tinkerpot part. So it's easier to extend the schema, and you can internally change more code without changing interfaces and having breaking changes. So, and then these schema tests are really sometimes a mess. So that's also a huge part. Yeah, and then what's the main reason I started to think about this was I implemented the schema constraints to connecting edges between vertices, and define which one, and then the find how did it work, and many places you have to fix. So it was really interesting to get deep into JanusGraph code. So I started to check out how, and then the last part was really short code. So also only a really small parts have to be changed to fix this, but it was really hard to find the actual parts. So yeah. Genau, the schema enforcement using a Tinkerprop strategy. I hope everyone knows what the Tinkerprop strategy is. I'll shortly explain what this is. So a strategy are enforced or executed after you send a Gremlin DSL to the server, and the strategy can be optimization or verification, or no, that's basically two parts of the strategy, and then you can merge parts of the steps together. So yeah, and then for the current schema constraints are you can add define vertex labels, edge labels, and property keys. And for the property keys, you can also add type checking, and then you can map property keys to vertex labels that only you can only map these properties to these vertex labels or to these edge labels, and then also have a type checking for property values. Yeah, that's basically the current schema. You can't do requirements that the property must exist on a vertex, or requirements that a property with the type string has a max length of 100 letters or so. Yeah, the proof of concept is basically only a single point of injection. That's allow us to really have a small impact on the complete path of JanusGraph, and easier to test. Then this is a strategy. I can show the code later, but it's only 100 lines to check vertex labels, property keys, and edge labels. And that's made it a lot easier than currently. You have to check it in 3 different points. Now you can check it in 1 point. So I will switch to the code if it's work. Yeah, that's each traversal you will send. I can show one traversal. Probably this would be a traversal. You add a vertex, then set it to use it as well. So here you added the vertex, and that's work because you defined the schema the vertex label, and if you don't add it, don't work. So that's only enforced by the schema strategy, because before you would use the normal part, current state this is currently disabled in this test. So, and then all traversals go through these schema these traversal strategies, and then you can check all steps. And if the step is add vertex, I will check the properties and the vertex labels, and these allow us to check all these 3 parts: the properties, keys, the edges, and the vertices. So, yeah, the code for the current example is behind the link. I will update the slides later. So, yeah, 2 is that we have to be able to configure this as an optional part of the strategy, and then reach the current state of the schema enforcement, and then probably deactivate all schema enforcement to reduce the internal alt code. So yeah, the second part is the schema access using a Gremlin DSL. This is the idea is to you can manage the complete JanusGraph instance by with a external DLV like .NET or Python, so it would be no longer necessary to use Java to interact with the server directly. So you can do everything on the client side, nothing on the server side manually. Yeah, currently you have to have server-side access to the JanusGraph and then to manage the schema, and it's completely different to manage the schema than normal, as before I said. And then currently the schema is not represented as a graph like its internal graph, so it's treated a bit different. So it would be cool to treat the graph like it's a normal graph, not some different extra management interface for it. Yeah. Yeah, again, the current proof of stake allows us to access the basic schema vertices, but it's currently really difficult to access the different parts of it, because you have to do some internal stuffs to show invisible vertices and then hidden vertices. So it's sometimes some are blacklisted by Gremlin, some blacklisted by some internal queries, and others are filtered by other part of the graph, and it's only a proof of concept that currently works. We'll show the code only on slides. So yeah, allow having a schema traversal source. That's like the credentials traversal source. To accessing the credentials graph, you can access vertex labels with these and property keys and edge labels. And that's only read. You can only read the schema currently, but it could be extended in future to also make it adding vertices. Yeah, that's would be the schema. That's probably a vertex and a property key, and the property is connected as a constraint to the schema. And then I will show some examples with it. So to access the schema, you can open a graph traversal like this, and then saying schema traversal source, and then you can ask for the vertex label, and this shows you have one vertices as added here as a vertex label, and then you can find the map properties that's connected to the vertex is connected to a property, and it's also one as connected here by this one. And then it's also possible to accessing properties as the same before. And you can see that you have to define currently also these schema names, because they are hidden, and yeah, that's internal stuff of the Tinkerpop graph hiding. And then you can see this is test one for the properties of the schema, and here's the test one for the property, and the same for the vertex. Oh, I did. So yeah, there's these schema DSL is really in the early stage. You can only read only stuff, and then it would be also make it configurable to work on client side. So probably open the graph as a management graph also, and then combining this with a strategy will also allow to completely manage schema manage a JanusGraph instance without accessing directly the server. Yeah, and then to get this into place, it would require a lot of work. We have probably start with a read-only graph strategy to testy strategy in production for JanusGraph. There's this is already implemented by Tinkerpop, and then the next step would be probably to enforce the schema using a strategy. Currently, this is done by internal stuff in JanusGraph, and then the visibility management could also be integrated into a Tinkerpop strategy to manage the visibility of vertices and properties in only one place, and then the last part would be accessing the schema with a Gremlin DSL in future. Yeah, that was probably all.
Awesome. Thank you so much, Jan. Okay, so for those of you who have recently joined us, there's a Q&A box at the bottom of your screen. You can submit questions there. Also, the recording will be sent out to everyone who registered for today's meetup by the end of this week, along with all of the presentations, contact info for our panelists, all that good stuff, as well as any Q&As that were answered via text and were not answered live. Okay, so let's go ahead and get started with some questions. Jan, what are the issues if we decide to not use Elasticsearch right now, but in the future want to access it?
You probably have to add a mixed index to a property which is currently not indexed, and then you have in future to reindex the whole property. I hope this answered the question.
Great. And if any other panelists would like to, they can type in an answer in the Q&A box to that question if you have any other input. The next question says, is there a best practice for designing the index model, or does it depend on the queries executed on the graph?
Yeah, usually in my experience, it's really dependent on the queries. And so it's best, and that's also really comes into play too, even when you're just designing the data model itself, like Ryan was talking about. So you're going to want to think about ahead of time what your use cases are, what specific queries you're going to need to support, what the SLAs are going to need to be for those queries, and then use that as input into your schema development process, which would include the structure of the model itself, and then also what indexes you decide to add. You definitely don't want to, take the approach of same as if you were in a relational database, for example. I know this is one extreme, but you don't want to take the approach, for example, where you index everything. That's usually a bad sign. So look at your queries and then use that as your guide.
Cool. Thanks, Ted. Would adding support for Elasticsearch later require downtime?
I will ask my colleague Florian shortly. Yeah, would adding support for Elasticsearch downtime, it shouldn't be, but you have to re-index the graph. So at that time, you can't use the Elasticsearch index.
Yeah, so like let's say you didn't even have Elasticsearch configured to start, even if you didn't have any indexes for it. But let's say you didn't have Elasticsearch at all. If you go look at the JanusGraph docs in the configuration section, you'll notice that there's different mutability levels, they call it, for different configuration options. And basically what that means is certain configuration options would require you to turn, your cluster would need to be down, or you'd only be able to have one Janus instance up when you made that configuration change. There's not very many of those, but adding a new index backend is one of those things. So if you wanted to add Elasticsearch, there would be some downtime, likely minimal, but there would be some downtime.
Cool, thank you. Are there any tools for query optimizations? Do we get to see what indexes are being used for a given query?
Yeah, you can use the profile command in Tinkerpop. I can send a link later on the answer. So that would be have, and some query optimization are done by JanusGraph using a strategy.
Alrighty, and I'm going to move over to some questions in the chat. If you're a panelist, you can head over there to see those. Alex says, thank you very much for the presentation. I really like Schema DSL. Is there any estimated time when it will be implemented so that we can drop current schema management?
There's no estimated time. I will probably start with the read-only part sometimes in the next weeks to get it done, to work it as a configuration, and then probably start adding feature in the future after and after. So it will take some time.
Okay. Rado says, I remember it was not easy to remove indexes and the mixed index had to be removed in the back end. Will it be easier in upcoming releases?
I don't know, probably Ted.
I haven't, I don't know if there's anything in flight for that. I'd suggest if that is something you're interested in, I would go in and add an issue so we could track that. But I can't think of anything off the top of my head to make that particular piece easier. But I know that there's a number of operational improvements that could be made around third-party indexing. So that would definitely be a good one.
Awesome. Another question, is it possible to bulk export the data from one Janus instance to seed it to another Janus instance?
There is a bulk dumper vertex program on the Tinkerpop side that you could use to dump your JanusGraph out into a format that you could then read back into another Janus instance. So that's one option. If you're, depending on your storage backend, another option too would be to just simply take a snapshot of the storage backend. So for example, if you were using Cassandra, you could snapshot the SS tables and then load them into another Cassandra cluster, for example. That would be the quickest way to do it. But yeah, so there's a few options for that.
Okay, we have time for a couple more questions if anyone wants to send anything in. Is it possible to rename the labels and property keys in JanusGraph?
For this, I think there's a API in the management system, but I'm not sure that is working correctly, and I can't say more about it. I can share a link to it, but so I hope this works. Oh.
Okay. Awesome. Well, if you have any more questions, feel free to keep sending them into the Q&A box. We have 2 more speakers left. If you need to drop off for any reason, that's totally fine. We will send the recording out to you. But if you want to stick with us, we would sure appreciate it. So next up, we have John Mertic. He will be talking about the new ODPI, a home for vendor-neutral big data open source.
Cool. Thank you so much. I'm going to bring up my slide deck here, and hopefully this works. Hopefully you can see my screen.
Yep.
Excellent. Excellent. Well, first of all, I mean, thank you so much, everyone, for welcoming me to your community and to this call here. You are surrounded by a number of fantastic technical presentations. I can categorically say this will not be one of them. I mean, not that it's not going to be fantastic, at least I hope not. It's not going to be technical at all. So giving you the forewarning ahead of time on that. Kind of a little background before I drop into this deck here. I had the pleasure of meeting members of the community. I met Jason Plurad at Open Source Summit back in Vancouver last summer. And, there was some discussion, within this project here. It's really, the technical work has been thriving. I mean, I can just see from the presentations here that we're starting to see some examples of this in the real world. But the challenge of how can this community help take itself to the proverbial next level? How can it get a larger constituency involved? How can it have a more structured community engagement strategy? How can vendors have a cleaner seat at the table here? And, the timing is probably good. As when I was spending time preparing for this session here, I did a little bit of research, and, really the graph database market is set to heat up. A lot of people saw 2018 as really an apex point, but it's really been looking into 2019. And when we're here at the Linux Foundation, start to see technologies that are becoming more and more of a cornerstone piece of really our society. Those are in areas those are the open source communities that we want to make sure that are invested into. Making sure that the community has what it needs to be successful. And it feels like a lot of that is starting to happen, certainly with the original alignment with the Linux Foundation. But how can we help take this message to market? How can we help partner with the organizations and just the users that are using this and help tell that story? How can we tell the developer story? How can we tell the story of everyone in this community who's doing amazing work? So with that, Jason and Susan Malaka from IBM, who I've worked with for a number of years, asked, maybe this group would enjoy hearing about what's going on with ODPI, especially now that it's going through a transformation and sort of getting out of the Hadoop standardization space, but looking more broadly of being a host for big data open source projects. And perhaps some of the stuff we have going on here, or just at least the structure, could be of benefit for the community. So that's a little bit of the background. Hopefully, I'm a developer by trade, so I'm going to keep this away from being a sales pitch because I don't think that's really a useful thing here. But more of just giving every information, and definitely happy to answer questions here at the end. The deck here was one actually that Alan Gates, who's from Hortonworks, now known as Cloudera, gave at Open Source Leadership Summit a few weeks ago, as we're starting to go to market and talk about sort of the new ODPI. So hopefully that was useful background there. It's a true statement. I say this: big data is driven by open source. That is just probably everybody on this phone says, yep, that's a given. All of the key big data efforts out there are open source. Whether you just look at traditional stuff around, Hadoop and Spark, whether you look at, the new stuff around AI and machine learning, things like TensorFlow, And yeah, heck, JanusGraph, right? The graph technologies are the leading ones are all open source as well. They're available all over the place. They're available as a part of Linux distributions. They're available as cloud offerings, SaaS offerings. The really interesting piece here is that, you know, the data technologies, they're getting the enterprise adoption, right? So these are technologies that are, you know, outside of the startups, outside of the disruptors. Now they're getting into the mainstream of technologies, and this is an area that's just going to continue to grow. You know, when we look at these projects, the thing that we've seen in the past there is they've been very much developer focused, which is a good thing because frankly, somebody has to write the code. And so you have to start there. But when you look at an open source community, you know that there's just a lot of different types of contributors. And especially for those of you who come from product backgrounds, you know, the personas that I lay out here are probably pretty similar, right? You have the developers that have the code. You have the domain experts, the people just understand the space, that are using the technology, that understand sort of the landscape. They have traditionally had a challenge of engaging not just open source, but I would say very more poignantly around big data open source projects, where the methodology of engagement is the pull request, it's the code contribution. So how do those stories get in? How does that filter its way in? Especially if you're not about writing a code, you may not know the inside of the code base. And then you sort of have those people that bridge in the middle there. You call them maybe the power user, right? So they're the people, they're not going to understand the whole depth of the code base. So it might be a big challenge for them to build up the confidence that they could be a core contributor, but how could they at least be the people that can just kind of take a peek under the hood, maybe contribute something there? And really with those is, how do you make your project open so that those people feel like they have a place at the table? And again, I don't know the depths of JanusGraph, so I'm not going to make judgments here. Maybe y'all are knocking this out of the park. But we do see as a tendency in a lot of big data projects is that itself tends to be a challenge. How do you get people other than the developers that understand the intricacies of the technology able to contribute to the table here? And, you know, the Linux Foundation, as we look at some of the larger foundations that we've driven, that's what that's one of the biggest areas we offer there. Because the technologies that we look to invest in and we look to make sure have sustainability, it's because they're actively used as a part of our society. Our society, you know, to some extent uses that to be able to function. And those projects going away, those projects not having what they need to succeed, those projects not having sustainability, really sets us back. And, you know, countless times we invest in, you know, areas such as the cloud technologies, web dev, networking, you know, really, you name it, you know, those core technologies that are really, really important to us. And that's where the Linux Foundation gets involved. And the way that we tend to get involved is through just building an ecosystem. And an ecosystem is larger than just a single project, right? It's larger than just the project itself. Now, where we focus on is the project. We focus on how do we make that project successful. So if you look at that full circle there, ecosystem, you know, we focus on how do we ensure the project has what it needs to be successful. And you know, at the get-go, that's, you know, a Git repo, bug tracking, you know, collaboration tools. But over time, that's events, that's meetups, that's blog posts, that's helping get this featured in technology press articles. That's, you know, helping, you know, define how this product is taken to market so that people can operate with it, or this project is, right? In general, open source projects these days are brought into commercial products, and the success of that productization, and that productization is maybe a two form. One, as you traditionally would think about it, is I would take the technology, I would put it in my product, I go ship it to customers. But another productization is I'm taking internal as my company, and I'm using this to power a core business functionality. Irregardless, the gauge point of the success of that project as a part of that product is, is that helping me be more effective, be able to solve the challenges for me or my customers in a cost-efficient manner, basically helping me save money on that front, or helping me make more money because of that, or is the path of the R&D that I'm gathering from this larger community is that saving and helping accentuate sort of where my core competencies are. Both of those together, in a sense, drive a profit. So whether that profit is I make more money, or whether that profit is it costs less money for me to deliver the same functionality. And if that rings up in a positive sense, these companies then and organizations tend to invest back in the projects, whether that be people, committers, or is that in dollars and other sorts of resources. And this is sort of the cycle that we look to keep going. We focus really much on that top. Let's make the project successful. And then the market and the industry and the vendors around it fill in the circle there to help complete that. So when we look at sort of what a vendor neutral foundation is really here to do, it basically is here to make sure nobody, have a level playing field so no one company can call the shots. There's clear governance, but it also lets people participate not only in the guise of them as an individual, but it puts it into context of that they're employed by a company, and making sure that that's a recognized thing. Because probably I would gather the vast majority of JanusGraph contributors and committers are employed by somebody and paid to do it. That is the model we see in open source these days. How can we make sure that those vendors, that is recognized as it's gone into the project there, and that there's still neutrality driven as a part of that, but at the same token, there's ways that one can contribute. And for companies, it provides also a clear path for them to engage as well. And this is sort of where in these foundations you see like membership structures for them. And it's less of like what often people would consider like an open source tax, but it's more of it gives them a way to help set direction, for the overall foundation, but then also gives them ways that they can corporately benefit from the development of this ecosystem. So it doesn't really have, it doesn't have implications per se on, the technology itself. The technology is always driven by the community. But certainly if you're looking to take this technology out to market, you would love to help you would like to help benefit from the momentum that comes from a foundation there that helps position each company in a vendor neutral light, but all as stewards of the overall work. And a lot of then what we do for these projects here is make sure that they have, not only just the infrastructure for development, so all of the things that you all are from a technical perspective are used to, but staff, like people that know how to get projects managed, not really so much in the technical community to some extent, but just how to execute on getting members more structurally at different companies on board, how to structure for events, how to structure for market activities. We sort of joke around there as we call it sort of the janitorial work of open source. And we say that, I guess, a little bit tongue in cheek, but really all of the stuff from a technical perspective, it doesn't really all that fun, or is just sort of a non-trivial activity we try to do to help make sure that do for the community to make sure it's sustainable. And then also the, how do we help engage across other communities as well? And how can we see some of those natural areas that fit in, which can sometimes be difficult if you're really deep into one community. It's sort of hard to see what's going on in other areas, or if there's other things to leverage there, along with all of the legal and release hygiene and things like that. And here again, talking about really sort of the things that can do on marketing half of things. Just very simple things of like help get you into conferences, help get talks all over the place, help see how to do meetups, how to kind of help have a person sort of just dedicated or team dedicated on, developing, website and social and blogging and just kind of all of those runway things that sometimes we see within communities that it's kind of thrown around between a bunch of people and it's everybody's sort of like half part-time job, but able to have somebody who's focused on that, but able to leverage the larger group here and the larger community to be successful with. And then also just getting in front of the industry itself and garnering that big awareness. I think one of the charts that I even saw in JanusGraph, I did some Google Trends searches, and certainly if you would, I would say if you look at a technology like Neo4j against JanusGraph, and you could definitely make the argument that JanusGraph is, sort of an evolution or two ahead of Neo4j. The Neo4j has a lot of the Google Trend mindshare. How foundations are in place to help focus on that problem and focus on that challenge, and drive that message forward, but not do it within the context of trying to sell product, and not do it within the vendor context, but do it within the thought leadership context. An example of ways that that's often done is through things like certification and training pieces. And this is an area we did a general sort of Hadoop mock in the past there with over 20,000 folks who enrolled within it. And we spent a lot of time on doing conformance programs for our projects. And this is sort of an area, and we'll talk about what Egeria did in this area. But this is a clean way here for people who are taking this technology and really wanting to put a flag in the ground and saying, hey, you know what, I'm not just using this code and just using it for the sake of using it and complying with a license, but I'm doing it as a member of this ecosystem and using it in a way that I'm a fair player with all the rest of them, for lack of a better term. So all of our solutions have perhaps interoperability. And I guess that's a good point within Egeria here. It allows, which Egeria, if you're not familiar with, we'll talk about, it's a technology around a single API for metadata repositories. It basically gives a way that, hey, anybody who's adopting this technology can say, hey, we are adopting it in the ways that the project intends it to be, such that we're interoperable with anybody else doing the same thing. So it begins to add that sort of level of trust for people using the technology. And again, we talked about, I mentioned this briefly here, but getting more people other than just the coders in the room is a huge area where projects fly. And you can look at this even in just even past open source communities and technologies that took off and didn't. A classic example, if you roll back the clock here several years, OpenStack versus Apache CloudStack. I don't know how familiar everybody is with both of those technologies. But, in the early days of both of those, when they were kind of came out about the same time, very neck and neck, many considered Apache CloudStack as the superior technology. That said, OpenStack, in its ability to get a broader ecosystem development and broader people engaged just beyond the coders, meant that technology took off. And that was sort of ended up being the dominant one within there. And that's really where we look to be here. I mean, we see that having more people, not just the coders, and maybe the people that are in charge of product, how can they have a seat at the table in an inclusive, in a standard way? how can the people within those organizations wanting to use this code and take it to market, and use this as, you know, a part of their strategy for as they approach customers, how can they do that? What are the ways that that can happen? How can it be done in a way that's not disparaging and taking over the project, but is respectful to it and from a point of thought leadership? And how can people that just understand this domain very well, but maybe just aren't coders, have a way that they can get involved? And for Egeria, that was a huge bit there. We can talk about it a little bit. So the distinctive things here: ODPI, it's open. Companies have a voice to get through membership, and then we focus specifically on that participation for non-coders. So let's look at what that looks like here, getting past sort of the theory here. So ODPI Egeria is a project that was formed under the ODPI late last summer. And the focus of it is a layer, an API layer for any tool that needs to leverage metadata within their application, so that they have a singular API to tap into. If you look at sort of the landscape before, metadata repositories have never really had any sort of standard API. Everyone has a different one. The average enterprise has about 60 or more of these metadata repositories. So the idea of Egeria is, let's define a standard API. The plus side of defining that is that it also enables these various solutions to federate with one another. So conceivably, if a tool, if a BI tool is going and saying, hey, I need the metadata for a social security number, and the first metadata repository queries doesn't have it, it can go federate with any other Egeria conformant metadata repository and get that information, right? So there's a huge technical problem there to solve. So that is a big part of it. There's a vendor piece to solve here, because the real magic comes here is that if everybody's on the same API, so how can we define a vendor path to engage? The end users need to evolve, because this is an end user pain point, and making sure that this tool has what it needs to be successful for an end user, and solving the challenges that they already have at the table, such as dealing with like legacy metadata stores that may never, that just may never be maintained or just not be, how can Egeria still play with those? And then frankly, then the people who are experts in this space, to know sort of where the rough edges are of managing metadata and what the impacts of it are. So it's a really, really interesting project there that's getting a cross-section of a number of those folks. I'll also add that there's connectors that are built for leveraging JanusGraph as well, for I can see from the source code. I don't know how well those are built out, but so there's a natural connection point between the two projects. All open source code, Apache 2 license, you can definitely check out. But what's interesting here is how do we get that collaboration? Because there is always in this space been there's been standards groups that have tried to solve the problem. There's been vendors that have tried to solve the problem, and there's been developers that have tried to solve the problem. And all of them have done it somewhat independently and never of having a full cohesive way of pulling this all together. So this was a project designed from the ground up to be a very code-first project, have a way so that everybody can have a seat at the table. So your way of influencing direction is not just contributing code, but it's also talking about use case examples. It's talking about, products that you might have coming out, realities of how you're using this within your organization. All of those people have seats at the table there. And then we're able to go take this, we're able to help make this project fly. And this has been really a great success so far. I don't have a slide on this, unfortunately. I got skipped out of this deck, but to date we have a community, probably about 15, 20 different active maintainers. And that's coming from basically one last summer. But that's a diversity also across about 4 to 5 different organizations, all sort of leaders in the space. So IBM, SAS, Cloudera, but also an end user of ING Bank who's actually having this major pain point as well. And we're starting to see more and more people coming into here, especially as we begin to work with this community to define what conformance is around it, which sort of adds another layer on top of what they're doing. The collaboration sometimes even isn't necessarily always code here. One project that we have is around doing vendor neutral perspectives on technologies in the space. And so there's one group here that is focused on the interaction of BI, AI, and Hadoop, and helping build guides here and doing that from across organizational function here, but speaking from an area of thought leadership. And this group has done a number of those publications. They just did their second one around business intelligence and big data. But again, it's an example of open source collaboration, but it's bigger, but it's bringing sort of those non-coders to the table there and giving them a space to engage. And when you have these diverse background, all of a sudden this opens you up to being able to tell a larger story of big data. And I would say of all of the projects here, that's something that they have certainly benefited from. We have great relationships around the press analyst front. And certainly every company probably that's represented in a project has good relationships as well. What we find is really unique from our angle is that we're able to reinforce the thought leadership positioning of the companies involved, but we're also able to uniquely put the developer and technology first, which is just a different relationship than an average company will have. Here's a really good tweet here from Merv Adrian, who's somebody we've built up a ton of influence with over the past several years, and helping sort of, and you have him there, really getting on board with what the community's about, really getting excited about the technology and helping share that with his groups there. And we've just been doing a number of these, since the beginning of ODPI, but now as we're really starting to drive deep into some of these different technology spaces, an organization like ODPI ends up being in a unique position to actually help drive influence with the people in this space. So I've got to the end, and normally my decks have this great slide in them that shows like this audience in the background and somebody sleeping. I'm hoping nobody's sleeping. If you are, this is why you're on a virtual webinar, so I don't have to see it. And if you are, there's no judgment. But again, I want to really just throw out that this, ODPI is up to some interesting things. Would really love the community to kind of take a step back and think of where it's hoping to go here and in the next year, 5 years, what its impact it wants to see on the market, and how it really wants to evolve as a technology. And even for the companies behind it, is as you're looking at similar technologies that have been delivered within foundations, is that an area where you're looking to help sort of formalize out the ecosystem and drive it forward in a vendor neutral way? And if so, ODPI might be in a good position to really help that growth. So I'll pause there. And I don't know, I'm looking at the chat. I don't see a lot of questions, but maybe Ashley, you see something that I don't.
Yeah, thank you so much. I hope no one's sleeping also, but we'll just keep on rolling. Some of the panelists answered a lot of the questions that came in. So if you are an attendee, you should be able to see all of the answered questions in the Q&A box. So if you want to go back and reference some of those, I'll read a couple of them off along with their answers really quick. Is there a plan to support versioning in JanusGraph, for example, when the underlying data store provides support? And Ted answered, I'm not aware of any plans to support this, but would encourage you to enter an issue or start a discussion on the dev list. I've done work with folks to do versioning at the JanusGraph model level where we attach version timestamps or effective time ranges to graph elements directly and then filter out versions at query time. So that's just one of the questions in the Q&A log. So you should be able to see those answered questions if you're an attendee. a question I do have for you, John, is we are planning to develop a POC using JanusGraph with Cassandra, where the user is free to add any property to a vertex or edge. What kind of problem can we face using JanusGraph?
That is a great question. I feel like we're probably getting into a depth of a technical question that probably somebody in the JanusGraph community is going to be better able to answer than myself.
Yeah,
so
maybe before we get to that one, Ashley, I had a few questions for you, John.
Sure.
So with these, open source community is this very kind of, by nature, distributed group of, individual developers and things like that. How do people start usually kind of interacting, say, with ODPI or like what are the mechanics of that process?
So I guess maybe trying to hone in on that question more of how do they start interacting with like a project like Egeria itself? Is that sort of where you're
Yeah, I guess, sir. How do you, in the past, have you seen these things kind of like organically, like within the project, like somebody will kind of propose this interaction and discuss within the community and then reach out or just do you have any kind of different stories kind of about that? I don't know if that question makes any sense, but
no. I mean, I think it's a common question with communities is like, you have a cool technology. How do you almost get people excited about it? Like how do people even just come to the table to begin with? How do they know to come to the table? Like, how do you get this in their visibility? And, a lot of where we use is kind of very faceted strategies. One is just events, things like meetups like this, virtual meetups, local in-person meetups, especially ones that end up being like co-located or near other events, or also can be sort of driven cross-functionally across other domains. So for example, we were at IBM Think last month and had a number of different sessions around the technology and pieces like that, right? We've done stuff at Open Source Leadership Summit or Open Source Summit. In the past, we've done a few sessions there. We've done things at, various FinTech events and also just getting within the communities where these people just very much naturally are. Mandy has participated in, several data practitioner summits and things like that. So I think that's sometimes one area that we see. Another is, for organizations that maybe have customer bases that are leveraging these technologies, we're starting to see an interesting trend where those customers, where predominantly in the past, they might have just sort of wanted to have the direct relationship with you and just that you as the vendor, and sort of looking to you for the solution to the problem. A lot of these folks are almost willing to skip up if they see open source is where this is coming from. Some of them even want to skip up, and if they see that this componentry of open source is very critical to them, they're wanting to participate in those communities. They're wanting to help guide some of the direction. They're wanting to help sort of lead the technology charge. ING Bank with Egeria is an excellent example of this. Like, this is a huge pain point. Like data, we have usually on our Egeria charts, we have this picture of a data landscape, and it sort of looks a cobbled together mess is probably a polite way to put it. It's overly complex. It's, all sorts of iterations of historical value putting in there. And they knew themselves, like they're a customer of IBM, they're a customer of SAS, they were a customer of Hortonworks. They could have just taken technology from them, but they're saying, hey, you know what? We think what we're doing is so important here. We want to be driving that use case in the open source technology itself. And we know it's not something that sits with any one vendor to solve. So let's work on it as a community. So we're starting to see sort of that is also a pattern that's emerging too, that customers sort of see those forward-thinking vendors within there. But then, I mean, after that, it's just, you know, some of the very runway material things, you know, being active on social and talking about, you know, when you're having meetings, meetups, you know, community meetings, things like that, you know, maintaining Slack channels and being responsive within there. Also just being proactive out to, you know, the press to a degree. So helping, you know, work with analysts and other press people, especially when you have milestones within the project, to start talking up, because those are often just kind of trigger points to get people engaged. So those end up just being a lot of the pieces. It would be great if there was like a one size fits all, but it's often a very scattershot strategy, but it's also a lot of very much low hanging fruit. I don't know. Was that helpful?
Yeah. No, that was great. Yeah.
Okay.
I appreciate it.
No problem.
I guess one specific thing on the, and maybe this isn't ODPI specific, but on the, being that you're a member of the Linux Foundation, on the press front, let's say JanusGraph was going to have some big new release or something. How do projects usually, is there like a press group, I guess, of the Linux Foundation that we could interact with to put a press release together, or what does that look like?
Yeah, so we have a full PR comms marketing cross-functional team that has relationships across a number of different parties or different press analysts within that community there. So, you know, not only does that as a service, which typically is funded through at the foundation or higher level project level like ODPI, not only is that service good at helping refine in what the message is, but also determining how to best target that and who should be, you know, who's the audience, who's going to care about this, are there natural events to belly this on top of, and then connecting, you know, key people in the community to helping be the spokesperson for that as well. So then there's also some natural affinity that comes in here. So that's kind of a high level piece of it. I mean, if that's something this community is looking into doing more, I'm happy to go with a more detailed answer within there, but hopefully that gives you a little bit of an idea of how we'd approach it.
Yeah, no, that was helpful. Thank you. Yeah.
Cool, thanks guys. I have a question here. Are there other projects at the Linux Foundation or elsewhere that might be looking to join ODPI? What would the criteria to join ODPI be?
Yeah. So we have a number of projects that are in the early stages of potentially aligning with ODPI. You know, until those get submitted to our technical steering committee, which is sort of an oversight committee that maintains an entire project life cycle. I don't want to talk on those projects' behalf because sometimes those are also efforts that are currently not open sourced. And so bringing it to ODPI would be a part of that. So I have to be kind of respectful of a lot of that. But we are starting to see interest. And frankly, we've really only started going public about our desire to host a number of different projects here within the last few months. I mean, just to be quite frank, we were using ODPI Egeria as sort of a test bed of can this foundation become a home for projects like this, similar to what like a CNCF or Hyperledger is doing? And we're finding that yes, and it's and it's actually a good thriving area. For the process of it, I can share with you a link. It's up in our technical steering committee sort of process area here, and maybe Ashley, I'm just going to put it in the chat if that's okay there. So there is the overall proposal process of what that looks like, and you can look through that there. And then you can also look at the stages for projects within ODPI. So we sort of maintain, kind of similar to other foundations, you know, we have an incubation stage where projects sort of start out, and it's an area for them to sort of come to grips with what they're, you know, what the problem they're working on, helping sort of build more diversity within their project from the number of committers, the project likes to see align with the core infrastructure initiative best practices badge, and just making sure they kind of have their stuff really together to be a sustainable project. And then that's what then moves it to an active stage there. So you can read those 2 links, hopefully give you a little bit more information on what that looks like.
Awesome, thank you. And then if you want to look up just a little bit in the chat, Alex says, John, I can't yet understand how to grow the community. We don't have full-time developers who work on JanusGraph, if I'm not mistaken. All contributors are part-time. How to build the community better in such a situation? I'm not sure if my question is clear.
No, I can understand sort of where you're coming from, Alex. And this is not an uncommon area for open source projects, because oftentimes it's worked on by fractions of people in their spare time, and it's not often, maybe it may not even be something that's entirely on the focus area of any company. This is sort of an area we look to partner with projects to help here, because again, we often find open source communities, you all are the technology experts. Like, you get this technology, you understand the nuances, you understand how it works, you understand the power of it. But in terms of getting that story out and figuring out how to multiply it, that's also an area. I mean, I was a former developer. I get that. That's a struggle area for many of us. And so that's sort of an area where we spend time and partner. Part of it is there's strategies we use with some projects. A lot of it is just improving some documentation, improving, awareness of what the project's doing, try to catch the people that are looking for the same problem and seeing if, hey, this is an area to help solve it, helping work on areas of governance, and also we find also establishing ways that vendors can also take talking about this project and their participation to market more formally. Because some companies also, they see open source, they're like, we want to be respectful of the community, we don't want to feel like we're hijacking it, help us understand sort of a good way to do that is. And we have a lot of practices there that helps each of the companies you're employed by have a great way of talking about their leadership in this area. So I would love to give specifics, but I would also need to also know the specifics of the challenges in the JanusGraph community. If the community is open to explore that, I'd be definitely happy to start sitting down and working through some ideas and things like that, and to see if maybe there's something we can do to help.
Awesome. Thanks, John. That was great. We are going to go ahead now and move on to our final speaker, Ted Wilmes. He's going to be talking about high-performance JanusGraph data loading. So, John, I think you have to stop sharing for Ted to share. And again, keep sending those questions into the Q&A box, and we will keep answering them after this next session.
I will get rid of this window if I can. There we go. Okay, great. Hi, everybody. My name's Ted. I'm a data architect here at Expiro. Work with Apache Tinkerpot project and JanusGraph, do a lot of graph database related work, among other things. Love all things data related. So really glad everybody came today to this meetup. Really good turnout. So just briefly, I'll keep this quick, but a little bit about Expiro. We're a consulting company. We do everything from UX and discovery work all the way down to software development, back end, front end, and everything in between. We don't only do graph work, but graph work is one of our big focus areas. We work with many different technologies. Of course, JanusGraph is near and dear to my heart, so that's what we're going to be talking about today. So getting into what we're going to talk about with data loading. So I want to start out with kind of what is the typical user experience that I see folks have when they start using JanusGraph, maybe for the first time. So they probably go, heard about JanusGraph, somehow decided they wanted to try it out. they go grab it, download it, unzip it. That's pretty easy. Start it up and get going. Maybe play around a little in the Gremlin console. And then a common pain point is, okay, I got this thing up and running, but how do I really actually get some non-trivial amount of data into this graph database? And so there's many different ways to do that. Today, what we're going to be doing is kind of talking about some patterns to help you with that. So data loading option-wise, there's a few tools that are actually built into Tinkerpop itself. So if you're not familiar, or if you're new to JanusGraph or haven't done much with it, you've probably heard us say Tinkerpop a few times during this presentation. Apache Tinkerpop is a graph processing framework that JanusGraph makes use of that provides us this Gremlin query language that you're actually using. So that's coming from Tinkerpop. And so Tinkerpop includes a few tools for actually loading data into your graph. The first is if you have some graph data that's a smaller amount of data, you can actually load it using this Gremlin. I have an example of one of these little Gremlin statements here. You can actually just read this file in directly into JanusGraph using one of these Gremlin statements. So usually, that'll work up to, there's probably no hard and fast rule. It's going to depend on your system, but that'll maybe work up to a few million or so vertices and edges. It's probably largely going to be dependent on the heap size that you can muster up for your JanusGraph instance. You also need to have your data in a specific one of the formats that Tinkerpop can actually load. So there's a little bit less flexibility on the formatting side there. Another option for larger data sets is there's a Tinkerpop bulk loader vertex program. This is something that runs on Spark. So you can make your data available to Spark via, say, HDFS or on a file system, and then load it into your graph. This can work okay. However, it's not always the most highly performant way to load data. Lastly, for batch loading, the probably obvious option is you can, of course, write your own custom code to do this batch loading, and we'll be talking about patterns that'll kind of fall into that category today. On the streaming data loading side right now, really your only option that I know of, at least others may have seen other projects, but the only option that I know of at this point is writing your own custom code using the language drivers for whatever particular language you're writing in. So if it's Java, using the Java Gremlin drivers. If it's Python, you could use our JanusGraph Python drivers, etc. So you have to do that kind of by hand though. So when we think about data loading into our graph, or really any other database for that matter, so what are our two main concerns? What are the things that we want to keep top of mind? First, probably performance. Unless your graph, let's say you're going to set up some production system, unless your graph is trivially small, you're probably going to be wanting to think about the performance of your data loading to make sure that you get data into the system. Either so you don't have to wait around for it, or to meet some actual specific SLAs about how up to date the data needs to be. The other part of this is high performance is great, but correctness, we cannot forget about correctness. So ideally you want the data that you intended to load to be actually what ended up in your database. We'll talk a little bit more about that later. So starting off with batch loading, when might you do batch loading into a JanusGraph database? So might be when you're, say, bootstrapping an empty database, or if even if you're running a production system, you may be able to tolerate infrequent updates to your data. So you might be able to, it's not uncommon for people to run some sort of nightly batch job to load some incremental data into their JanusGraph instance. Or you might want to do a batch load after you've done some sort of computation over your graph. Maybe you've run a graph algorithm, produced some output, some large amount of output. You might want to load some form of that output back into your graph. So those are all good examples of batch loading scenarios. So when it comes to performance, we're going to look at these common bottlenecks and what we can do to help remove some of these bottlenecks to improve that performance portion of what we're concerned about with our data loading. So I'll talk about these in more detail, but we're going to have bottlenecks associated with ID allocation. There's JanusGraph storage and indexing tunables, transaction sizes, your write to read ratio, and then also constraint enforcement. All of these things can potentially slow down your loading. So those are the things that we'll discuss. So first, let's get started with a kind of concrete example of what even happens, under the covers when you're loading some data into the graph. So this is a kind of high level, a little bit more simplistic view, but here's the write path for if you're writing a vertex into JanusGraph. So over on the left, I'm adding a vertex, a person vertex. It has a few properties on it, and then I'm going to commit this transaction. So first thing that happens is JanusGraph, for all of you who've used JanusGraph before, and maybe for those of you who haven't, but there's an ID associated with all your JanusGraph vertices. It's just a long. And now this ID needs to be allocated when you first create the vertex. So you're not giving it the ID. JanusGraph is going to assign this ID. That's kind of a built-in primary key that is assigned behind the scenes. So we need to assign a new ID. Then we're going to store this mutation locally. So say you're running a client application, you execute this command against the server. The server then stores this mutation. Maybe you add some other mutations into the same transaction. It stores all those. And then finally, when you call the commit, it's going to actually flush that out and store it durably in the JanusGraph backend. So ID allocation is a very common bottleneck that people can run into, especially if they're trying to really push a lot of data into JanusGraph at once. So there's a few operations in JanusGraph that require consensus among all of the JanusGraph instances as it's running. So a little bit about JanusGraph architecture. So we have JanusGraph. Say we have more than one JanusGraph node. So we have multiple JanusGraph JVMs. And then just for the sake of argument, let's say we're running a Cassandra cluster behind these JanusGraph nodes. The only communication that happens between JanusGraph instances happens through the storage backend itself. There is no direct JanusGraph communication that's happening. So the thing that we want to avoid with these IDs is we don't want to hand out the same ID to two different vertices. So we want these IDs to actually be unique. So to do this, there's a round of consensus and that has to be undergone to actually retrieve these blocks of IDs for the different JanusGraph instances so that we do not have ID collisions. Now, there's some defaults that are set for these block sizes. So you can see down here on the bottom of the screen, the default ID block size is 10,000 IDs, and the default renew percentage is 0.3 or 30%. So when that ID block of 10,000 gets down to 30% full, that JanusGraph instance will go and asynchronously attempt to go retrieve a new block of IDs. This can cause issues though with those defaults. So if you're trying to pump a bunch of data in, this is an example of a performance graph from a Gatling test that I ran to do some load testing. So in this performance graph, we can see here, if you look at the scale on the left, we're measuring the response time of our writes to the JanusGraph instance. And so you can see that our P99s and our maxes, we have these periodic spikes that go above 500 milliseconds. So that's pretty bad. So what's happening in those instances is JanusGraph is having to go and do this expensive round trip to go get a new batch of IDs and coordinate with these other JanusGraph instances. Now, if we increase those ID block sizes, we can reduce that contention so that these JanusGraph instances that we have are not going back and forth quite as much. And so here I've increased the block sizes, And now you can see a big drop. Now on the scale on the left here, response times, our maxes are maybe peaking over 40 milliseconds on occasion, but overall it's a much smoother latency distribution for our writes that we're pumping into JanusGraph. So on the, I won't spend too much time on this one, but just to mention there are a number of different tunables related to the Gremlin server and the actual Tinkerpop drivers. So you can read about those more in the documentation and the Tinkerpop project. But you can go look at these things to adjust things like connection pool sizes and things like that, and also sizes of different thread pools. And that will allow for you to have more parallel operations going on at once on your JanusGraph server. So another option or another problem that folks will run into, and again, this is probably if you've done anything with, say, relational databases, this is also the same sort of thing that people run into when they're first using a relational database. Let's say you're trying to write some data into your JanusGraph database. We have some data on the left here. We're going to add some new users into JanusGraph. And so we have 3 different users, and we'll generate one Gremlin query for each of these users that we want to add and commit that transaction. So what happens here is there's a lot of overhead, just a network overhead of sending the command over, committing that, and we're doing it for each one of these, so that can be really slow. So just like in a relational database, we can actually batch up our writes. So here we're taking those 3 inserts and we're actually rolling them into one single Gremlin statement and sending that over at once and then committing it. Now, usually you would do a batch much larger than 3, but I'm just showing that for an example here. So what is a good batch size? Usually the batch size is, you know, it's going to be dependent on the size of the data that you're inputting. And what you want to do is actually run some tests to look at what a good batch size is to figure it out. So what you'll usually see is on the bottom here, and this is just kind of notional graph, we have a batch size. As the batch size increases, the throughput increases up to a point. After a certain point, we'll end up overloading the server probably, and we won't have any more gains and it'll drop off. So ideally what you want to look for is kind of around where is that peak where given some particular write load onto the system, what is the right batch size for that? So usually I kind of started around like 100 vertices or so as a good just kind of rule of thumb, and then take it from there, adjusting up and down as needed. So write to read ratio. So when you're writing data into a system, a lot of times I mean, by virtue of it, we're talking about data loading. We're thinking just about writes, but a lot of times your writes actually have some reads involved. And those reads may be related to you having to go see if something, say, already exists in the database before you write it, or maybe reading something, calculating some derivation of it and writing it. So you're going to have a number of these reads, and these reads are going to eat into your ability to write, just because you only have some, you know, there's a limited amount of resources on the system, and ideally we would like to have more writes than reads. So spend more time writing than we're actually reading. So how can we avoid these reads? So the nice thing about batch loading is, in a lot of cases, you can really do a lot of pre-processing on your data before you load it into the graph. So that is one thing you can do here. So as if there's things where you traditionally maybe would have read something out of the graph first to do some calculation, perhaps you can do that before you've even loaded the data into the graph in a pre-processing step, and then load that data in. That'll speed things up greatly by reducing the reads. Also, we can order our data load. Since we're doing a batch load, we could load all of our vertices first, then load our edges, so that when we're loading edges, we're not having to go and see like, hey, does this thing actually exist first? Do I need to create this vertex? So to do that nice 1-2 order of vertices and then edges is something nice that usually batch loading will allow you to do, where in a stream loading scenario, you may not have that ability. The last one, which gets a little bit into the danger zone, but can be a good idea sometimes, is we can disable JanusGraph vertex existence checks. So JanusGraph, actually, to give a concrete example here, we'll look at now the right paths for edges. So in this case, we're looking up 2 vertices by IDs, and we're going to add an edge between them and then commit that. So what happens is JanusGraph goes, in this case, it goes and retrieves that first vertex to make sure it actually exists. Then it retrieves the second vertex. And then, like before, it stores that local edge mutation from your add-e, and then it flushes that data to the storage backend. So that's all good. But what we could actually do is, you'll notice here that we had 2 reads just to actually do our single write of that edge. And so what we can do is there's a storage batch loading setting. So if you are certain about the data that you're loading and you know your IDs very well and you have a good handle on everything, you can turn this storage batch loading to true, and that will turn these checks off to basically go and make sure those 2 reads will be removed so that you will only be doing a single write. So here in this case, we've turned it on to true. We do the same query. We get 0 reads to verify the existence of those 2 vertices and then 1 write. Now, the downside to this, of course, is if you don't have a good handle on your input data, this could lead to data corruption or incorrect out-of-date data. So, usually what I do with this is good if you're doing an initial, say, bootstrap load, but it has less value probably after that point. Or if you're just setting up, say, a non-production type system and want to load a lot of data quickly, this can really increase your throughput as you're writing data into the graph. So on the stream loading front, when would we use stream loading? So data arrives at a high frequency, and we want to update it frequently in our graph. We want to ingest our data as soon as possible. So as soon as we get a hold of it, we want it available to our end users. So we want to write it right away. Or maybe we want to maintain some continuously updated metrics based upon data that's coming into the system. So those are all good uses for stream loading. So on the bottlenecks for stream loading, we share a number of bottlenecks with the batch loading, of course. ID allocation is still a big thing. You need to look at that. Then, of course, there's the tunables related to JanusGraph and the storage layer and all that. But we have a few different ways to handle these other ones that we discussed previously. So we have transaction sizes again, write to read ratio we'll talk about, and then a new one here that we'll talk about, constraint enforcement. So in a streaming environment, instead of, say, reading through some single file that we're going to batch load and then batching that up into transactions of more than 1 vertex, we're going to need to do this in a streaming way. So depending on if you're using, Kafka streams or Spark streaming or whatever it might be, you'll want to look at those different environments as you're writing out your streaming job. See if there's some way to do, say, some windowing or aggregation of these different elements that are going through the streaming pipeline so that you can batch them up before you save them to the graph instead of, say, just saving them one at a time. So if you have, a message come into a Kafka topic that's going to result in 1 new vertex being added into your JanusGraph, you want to see if there's, say, some way to batch those up so that you can actually store more than 1 at once and improve your performance. Now on the increasing your write to read ratio side, so streaming's a little bit different for this in that we want to basically be able to have values that maybe we're going to commonly use available for us so that when we write this data, we can potentially avoid going back to the graph to get this data. So let me give a concrete example here using, this is basically inspired by the Kafka streams. So Kafka streams has a concept of a stream, K-stream and a K-table. So let's say I'm looking to load I'm getting these messages in. We have this sample message where I'm getting a source person who sent an email to another person. So Ted sends an email to Brian. This is going to result in this Gremlin statement. So ideally, I would like to not have to potentially say, go look up that Brian vertex or that Ted vertex every time that I write this data in. Let's say I need to really pump like tens of thousands of these things into the system at once. And so to avoid those reads, what can we do? So one way to avoid those reads is if we can map those email addresses to their JanusGraph IDs without actually going back to JanusGraph to determine that ID. So one thing we could do to do that is in Kafka streams, there's this concept of a K-table. And a K-table is basically, you could think of it as we could have a kind of key value map of email addresses to JanusGraph IDs that would actually be stored local to the stream processing that's happening. And this could be populated from, let's pretend we had another topic here that was handling user creation. So when a user got created, a user would be created in the JanusGraph system, and then this K-table actually would be populated with the mapping from that user's email to that user's JanusGraph ID. So now when we get these input messages in, instead of going to say grab the ID for that user from JanusGraph in that Gremlin statement, we can actually look it up by joining our stream against this K-table. Then when we go write that data into JanusGraph, we can simply reference those IDs instead of the actual email addresses to create that edge, to do those lookups and create that edge. And if we have storage to batch loading true on, that'll avoid actually even doing any reads. And in this case, we're doing 100% writes just to write that edge, no reads. So we could really pump a lot of these messages through. Again, you may only want to do this in certain spots where you have, really tight control over your data, and that you won't end up with any data corruption issues. So this is more of a tool that you can keep in your back pocket when you really do need to do those, say, 10s, 20,000, 30, 40, 50,000, or 100,000 or more writes per second. This is a good way to get towards that. So streaming makes constraint enforcement a little more challenging with an eventually consistent backend. So JanusGraph, of course, supports a number of different backends. And most of the distributed backends, all the officially supported distributed backends right now, none of them are actually ACID. We do have a new adapter we've written over here at Expiro for Foundation DB that Foundation DB is an actual ACID, distributed ACID storage backend. But the other ones that are most commonly used, Cassandras and the big tables and HBases, aren't actually ACID. So doing constraint enforcement is a little more challenging. So when I say constraints, what do I mean? I mean things like uniqueness constraints. I mean maintaining application level invariance. So maybe there's certain rules about how the data should be that the application is trying to maintain. And then also referential integrity. So like if I have a vertex with an edge to another vertex, I ideally never want to have a vertex that has just an edge to no vertex. So these are things that we need to think about if you're using an eventually consistent backend in a high concurrency environment. So there's a few options for uniqueness constraints. So one way is Janus does have its own internal recipe, and you can do this at the schema level. So you can set uniqueness constraints on properties or on properties that are indexed. That'll work up to a point, although that's not foolproof. One thing that sometimes people will do is you'll see them do something like this, where they're just writing this in Gremlin. Say we're trying to add a new user into our system, Ted, and we want to see if he already exists. If he doesn't exist, we'll create him, and we will then commit the transaction. If he does exist, we could roll back or whatever, commit there. It doesn't really matter. The problem with this, though, is what do we actually mean by transaction here? So Apache Tinkerpop is what's providing this concept of a transaction in this Gremlin syntax, but it doesn't give you any sort of guarantees. The guarantees come from the Janus implementation, but then also ultimately from the actual storage backend that you've decided to use. So an HBase versus a Cassandra, or versus a Foundation DB, they're going to have different guarantees they'll provide to you. So on the transactional spectrum, like I said, we have eventually consistent all the way up to ACID, or if you're running a single node, you can also use Berkeley DB right now, which will give you ACID support. But the problem that we can run into, just to illustrate the problem with these eventually consistent backends in certain cases, if you're not planning this at an architectural level, is here's a little example. So using that previous example, I'll demonstrate basically a race condition here. So we have user 1 comes into the system. I check to see if TED exists. That node then decides, oh, it's a good time for a garbage collection, or something else happens. It basically pauses. Meanwhile, whether, say, we have a request come into another Janus instance. Now, in this case, it goes ahead and it executes this, basically that whole chunk of code I showed you previously, adds the user in. Over on the left, though, it finishes up its GC. At the time of checking if the user existed, it did not exist, so it still thinks that user doesn't exist. So it more than happily goes and adds another TED. So you end up with 2 TEDs into the system. So the storage backend in that case, Cassandra, is not going to stop you from doing that. So like I said, you could use unique constraints, but there's some issues with this. One, the locking implementation isn't foolproof for all distributed failure scenarios. But the other bigger one is that this adds a fair amount of overhead into your writes that are involving these properties that are involved with unique constraints. So you can get a real hit to your ability to write data into the system with this. If you don't have really high ingest requirements, it's probably not a big deal at all, and this is fine. But if you're trying to get a lot of data in the system, this can really slow things down. So another option is use a ACID backend. Like I said, Berkeley DB, which is part of the actual distribution in JanusGraph, or we have this experimental Foundation DB storage adapter. Another option is to use external locking. So you could, instead of me just going over and checking to see if, say, TED's in the graph or not, we could potentially write a lock into another external system. So we'd have some coordination happening, say, using Zookeeper or Redis outside of JanusGraph. And actually, if you want to read a little bit more about some interesting approaches related to this, Florian, who's on this call too, he's one of the JanusGraph committers. He has a really nice blog post about this, link down there. The thing that I'm going to talk about is partitioning our inputs. So remember, again, we're talking about streaming data loading. So how can we enforce these, say, uniqueness constraints without adding an explicit uniqueness constraint in, and without, say, using some sort of external locking system? So here's what a lot of people do. I've been guilty of this in the past, is cross your fingers approach, which is, okay, let's say we have some API, it's hitting JanusGraph. We'll write a bunch of data to the API. API will just send a bunch of requests to JanusGraph, and we'll just hope everything's okay. The first thing you can do is take that, instead of just writing a bunch of stuff concurrently, is you can literally remove all the concurrency. So even though you're getting a bunch of concurrent requests in, theoretically, we could single thread our communication with JanusGraph. So in that case, if you think back to our checking if a user exists example, we could say, hey, does this user exist? Yes or no, and then make a decision. We know nobody else would have done anything in the meantime. Of course, this is untenable because, again, unless your performance requirements are incredibly low, this is really going to kill your performance. The thing we can do, though, is add that concurrency back in by partitioning our inputted data. So let's take say we're getting all these requests in to add these users into the system. We could actually partition those concurrent requests that are coming in by, say, the email address or something like that, so that if, say, the TED email comes in, he's always going to end up in the same partition. What this lets us do then is still have concurrent reads and writes against this JanusGraph single or multiple instances where we have basically a serial type behavior at the partition level, but across partitions, we're able to do more than one thing at once. So this is a really good way to do that. Although it requires upfront planning and understanding how you're going to want to do your streaming topology. Certain workloads are going to be more challenging to partition than others, so that is a caveat here. So with that, I know we're coming up on time. So next steps, hopefully, if you haven't used JanusGraph before, you're interested after this wonderful meetup today to go try it out, or if you're already a JanusGraph user, hopefully you will continue to have success with it. So I will leave it at that. And what questions do you have?
Thanks, Ted. So we've got about 10 minutes left for Q&A. We're going to stop right at the hour mark. So I'll go ahead and get started here. Can we have a custom ID? And if so, is there a length restriction?
Yeah, there is custom ID support in JanusGraph. You need to, I believe you have to map your IDs though back into the long space. I haven't actually used it. I don't know of anyone using it, but it does come up on occasion where people are interested in potentially using it. So it's probably one of the darker, I guess, less well-known portions of the code base, but there is support for it.
Cool. And Ted, for the sake of time, I'm going to let you look in the Q&A box and answer ones that you think are.
Okay. Cool. Sounds good. Let's see. Okay. Just getting caught up here. Okay, so can you talk a bit more about what's going on with the optimization of loading vertices, then edges? This keeps jumping around on me, sorry. You mentioned that if we load all vertices before edges, we don't have to check for the existence of the vertex. Is that check something that the graph engine no longer has to do? Yeah, so there, what I'm talking about is you don't have to basically have that extra logic to say conditionally create vertices if they haven't already been created in the system. So you can just kind of cleanly partition out two kind of portions of your batch load. The first one is just going to be a bunch of add V's, and then the next one is going to just be a bunch of add edge Gremlin statements, looking up the vertices that you previously created. Usually you're going to be looking up those vertices by using some sort of surrogate key or ID field that you added in when you initially loaded these. Okay, for the let's see. Any example implementations for external locking mechanism? I think that blog post that I mentioned in here, I'll go back to it, has some examples of that. So I'd recommend checking that out. That's a good example. For the GC that causes temporary sleeping, example on adding users for Foundation DB backend that has transaction support, can it guarantee that only one user gets added? Yeah, so if you were using ACID backend like Berkeley DB or Foundation DB, in that, if you think back to my example where you had those two concurrent transactions, one gets paused. What'll happen is when the second one, let's say we're using Foundation DB, or when the first one that had the GC pause gets actually submitted, Foundation DB will notice that there's a conflict on that transaction with that previously committed transaction. Basically, like the state of the data will have changed since the transaction started on that one. So yeah, even if it's a GC or network or whatever, in that case, it will still protect you from that race condition. You can go in and basically just simulate this on your own in a Gremlin console, even if you just open up, say, 2 transactions and play with it. So yeah, you can try that out. But yeah, it'll handle that scenario without issue. We are planning to have close to 2 billion nodes, not yet loaded, still trying to figure out the details. I wonder if some people have tried loading large data set and have some pain points to share. The biggest pain points that I see folks usually have are really around performance. And so I would suggest that that you kind of look at these different recommendations I provided and take those into account. But that's usually what folks have issues with. I think the other pain point is we have a batch loading tool that we use internally. We haven't open sourced it at this point, but maybe we'll at some point. But there is probably a need for a good out of the box kind of data loading a tool for JanusGraph to simplify that for people, that would kind of take all these different things into account. Any data migration experiences like from Titan Graph to JanusGraph? So data migration from Titan to Janus, you don't really, the storage format is the same. I think you need to go, you would need to be on Titan 1.0. If you were on Titan 0.5 or before that and wanted to go to JanusGraph, you'd have to do an export and then import it into Janus. If you're on 1.0, you can go directly up to Janus. To the panel. Okay, so to the panel, do you have any idea of what the impact, if any, of Tinkerpop 4 will be on Janus? That's a great question. Feel free to jump in anywhere else too, but I'll give my take on it. It looks like, so I think it's a little bit hard to tell at this point. As folks maybe have seen, Marco of Tinkerpop Gremlin fame has started on Tinkerpop 4, but it's really just started out. You know, there's already some, I mean, conceptually it's an extension of Tinkerpop 3 in certain ways. They're definitely inspired by it, but it's going to be I believe at least it seems a complete rewrite. So it's really hard to tell at this point, I think. But I think, I mean, historically speaking, Tinkerpop has been, at least in my opinion, very well done as far as making it easy for the graph providers to integrate it into their systems. So I would expect that the same will be true for Tinkerpop 4, and hopefully I think there'll even be some simplifications on our side. But I have a feeling it'll probably be a non-trivial amount of work to really take advantage of the benefits of it, though. So
I'm going to read off a question real quick in the chat.
Yep.
We use JanusGraph as a high-performance path computation engine and need to synchronize information in the graph database with the information in the primary database. What is the best strategy? Audit the 2 databases and make delta update, or clear graph database and repopulate the graph database?
Yeah, that's a good question. Usually, if you have the metadata necessary to calculate deltas, my preference is usually to do incremental updates. So let's say you were trying to pull updates from a other database into JanusGraph. If you have the necessary, say, timestamp or versioning information in that system, then you could pull deltas, and that would be a good way to do it. Now, if you don't have that information, then it could be pretty hard. Well, it could be computationally intensive depending on the size of the data to actually go back and do a diff. So in that case, maybe you're better off doing a full reload. So I'd say it depends, but if you have the metadata to identify deltas, I would suggest incremental loading. Okay, let's see. Any specific recommendation for doing upserts in JanusGraph? Any recommended distributed locking mechanism? So doing upserts, you can do it linguistically. So in Gremlin, you can write out a upsert, but there's not right now. That doesn't translate into what I would consider like a single atomic upsert at the actual, say, Cassandra level. For example, DSE graph can do like a true upsert. Which is pretty neat. JanusGraph doesn't really have that right now. So right now, the thing that you need to do is with the upsert is really you just need to be concerned about like that race condition that I outlined for you, or having something like the uniqueness constraints enabled. As far as recommended distributed locking mechanisms, I've seen people have success with Zookeeper. I know like Redis is also, Redis locks are out there as a potential option. I think some people have used Hazelcast in the past for distributed locking. So I don't really have any specific recommendations there though.
Real quick, before we answer any more, I just wanted to say it's the top of the hour. So this is when the meetup was scheduled to end. Ted, if you have time to stay on and answer a couple more questions that we have, we can do that.
Cool. Yeah, I can.
Cool. So for those of you who need to drop off, feel free. The recording will be sent out. The Q&As will be sent out. The presentations will be sent out. Lots of good stuff will be coming your way, and really appreciate you joining us. For those of you who can stay on, we're going to keep answering questions for the next few minutes.
Okay, let's see. So does adding a new node cause some, does adding a new node cause some temporary slowness as well, because the new node has to coordinate with old nodes for ID allocation? So the way that it works, adding a new JanusGraph node isn't a heavyweight operation. The ID allocation in the scheme of things is pretty quick. The problem becomes when you have a bunch of JanusGraph instances trying to all grab ID blocks at the same time. If you've already tuned your ID blocks so that you're not having to go and grab ID blocks, say, multiple times per minute or something like that, adding a new node really won't be that big of an issue. There'll be a little bit of a delay on that particular node as it grabs that first ID block, but it won't affect the overall performance of the cluster. We are using TitanDB with HBase, and one of the main pain points is running reindexing. Runs for a long time, fails sometimes, needs to stop ingestion. Is there any changes to the core reindexing module in JanusGraph? Right now, there have not been any changes to the core reindexing module. So I think that's definitely an area that could use some improvement. Somebody had asked earlier if there was a way to do reindexing with Spark, and right now there isn't a way to do that. I think that would definitely be a good addition though. But yeah, that's still operationally, that's still a challenging area for Janus. Yeah. Let's see. I'm using custom IDs during batch ingestion to maintain idempotence. Is there any downside for this approach? Like I said, I don't have personal experience using the custom IDs. I mean, it should be fine. It's just not an area I'm horribly familiar with. Do JanusGraph upgrades require downtime? What measures should we take when updating versions? So that's a good question. JanusGraph upgrades, in the past when I've done upgrades, there has been downtime. I would not be surprised though if, especially on minor version upgrades, and possibly even some of the major version upgrades, you could potentially do a rolling upgrade. The issue may come down to more on the Tinkerpop driver side. So if we change Tinkerpop versions in JanusGraph between two JanusGraph versions, which usually is the case, you may run into some driver incompatibility issues. And so that could be one potentially challenging thing. Now, to get around that, you could do something like, if you have a service that's using JanusGraph, you could potentially also do a rolling upgrade of that service where you were upgrading the drivers on some subset of that service's instances that were deployed. So it would probably take some work, but I feel like you probably could get a zero downtime upgrade, at least in some cases.
I'm gonna hop back over to the chat real quick, if that's okay.
Yep.
And thank you, Ted, for answering all of these. I know you're rapid fire right now. We are using a query that tries to retrieve edges of a certain from the graph. It is resulting in horrendous performance. Even though Gremlin supports this operation, is it not a pattern that is encouraged, that is trying to load edges without fetching the relevant vertices first?
Yeah, usually you're going to want to grab the vertices first, just because of the way the storage is laid out. So yeah, I'm not surprised you're having issues grabbing those edges like that. Yeah, so if there's some way to reformulate that to do it as a vertex first approach, I would suggest that. Let's see. Do you have any tips for how to handle a scenario where we have frequent graph updates, but where in the majority of cases the vertex already exists and the data has not changed? How can I minimize the performance impact of all these attempted updates where the only thing that changes is that the TTL on the edges is refreshed? Let's see. Yeah, so a lot of times for something like that, this gets back to the whole minimizing the read sort of thing, is I will, and it depends on the size of the graph data that we're talking about, or the vertices that you're particularly interested in updating. But let's say there's some subset of your graph that forms kind of like master data, and maybe it's a few million vertices or something. You could easily store that information cached in, say, some other portion of your architecture, where you could check, say, a local in-memory to see if something already exists without going to the graph. So that's something that I'll commonly do if I am in a scenario where I need to ensure as high a performance as possible. Let's see, one idea for a backfill we had is to run Janus embedded in a MapReduce process, since nodes can be dynamically added to graph, say in a data proc or data flow job. Any advice or concerns with regards to this idea? My only concern with that sometimes is every time a Janus instance is created and kind of registers itself it adds some metadata into the storage backend. If you end up starting lots of Januses and tearing them down, it's possible sometimes to get some that are lingering even though they're gone. And so that can cause issues when you're trying to do reindexing or other things that require some consensus between all the Janus instances, because Janus will try to go and say, hey, I need to hear back from all these nodes, other Janus nodes before I do anything. So that would be probably my only concern there, would be to have, a bunch of kind of these very potentially short-lived Janus instances, and you may need to go manually remove them if they kind of linger in the metadata. So if a new node is never committed to the graph and rolled back, does the allocated ID grab get returned to the ID block, or does this use up another ID still? I think it gets, that's a good question. I don't actually know the answer to that one. If I was gonna guess, I would say it's used up, but I don't know. That's a good question. Yeah, I'd have to go look at the source for that to see. What is recommended way for JanusGraph deployment, embedded mode versus standalone JanusGraph servers, or JanusGraph together with storage backends? That's a really good question. Yeah, that's one of the challenges also for people getting started with Janus is we have all these deployment options. I personally, I don't really recommend running it embedded. I prefer to run it either standalone with a separate backend or co-located with the backends. And to be honest, that really has to do with being able to scale the JanusGraph, your JanusGraph installation separately from whatever application is accessing the JanusGraph. So if I'd like to have, if I would benefit from having, say, twice as many Janus nodes as, say, API, like microservices, I'd rather just scale the Janus side out than have to scale the microservice side up. So that's usually my preference, is basically not to run embedded. And then as long as there's some benefits to co-locating JanusGraph with the storage backend, especially if you don't have a ton of data. So let's say you're running a very small Cassandra data center and a lot of your reads could be actually served off of the local nodes that your JanusGraph is co-located with. Then there can be a benefit from a latency communication between JanusGraph and the backend perspective. If you have a ton of data spread across a number of storage backend nodes, it's, the benefits probably not going to be as great because you're going to be having to make these cross node calls anyway. So that kind of depends on data sizes. So our JanusGraph drivers backwards compatible? Following up on upgrade question, we're running Janus remotely, so in what order should we update our remote server and client without taking downtime, if we can do rolling upgrades on the server side? So first, I should say I was mostly just thinking out loud when I was talking about rolling upgrades. I would suggest if you're interested in that, try it out, but definitely don't just do it straight in production. It's the drivers, really, you're going to be looking at that Tinkerpop driver version, and you're going to need to look at the delta between the Tinkerpop driver version of what you're going to and what version you're currently on. Really, the only way I would ever trust this is if I tried it out and actually worked. And that would be on even if this, say, works one time, it may not work the next time depending on what changes were made on the driver side. So you would really need to try this out on a case-by-case basis. Let's see. Since JanusGraph upgrades may sometimes require downtime, are there plans to provide tooling to seed another instance using the old running instances in case we can't afford downtime? I guess, with that, I don't know of any plans for that. Though I think that could be done right now, probably by either copying stuff at the storage layer and then standing up a new JanusGraph instance. But of course, you'd have to deal with, if you're ingesting data this whole time, you still need to keep them in sync. But there's no plans for any like Janus specific tooling for that. Can we have Janus serve read queries from replica of the storage, so read and writes take different storage configuration? Right now there's really the way to do that, using Cassandra as an example. Probably the only way you could do that would be as if you had, say, 2 Cassandra data centers and you had Janus instances connected to each one, operating at, say, like local quorum or some local local one or local quorum, whatever it might be. And then you could drive all your write traffic to one set of Janus nodes on one DC, and then all the read traffic on the other one. That's the only thing that comes to mind. So I don't think I can't think of another way to do that routing at the Janus level. JanusGraph encodes the data stored in the storage backends. Any way to decode it? Technically, yeah, you could decode it, but you'd have to go and get pretty comfortable with the serializers in the code base. But yeah, I mean, technically, everything you would need to do that is in the JanusGraph project. But yeah, there's no tool to do that though. But you could definitely make something that would do that.
Awesome. So that was the last question in the Q&A box. We are going to answer one more from the chat, and then we'll call it a day.
Okay.
Can you share some stats on the biggest graphs you have seen in production in terms of number of vertices and edges and corresponding hardware config?
Yeah, probably on edge counts, probably in the 10 to 20 billion edges. And I'm trying to remember on the vertex side of that. To be honest, I can't remember the vertex side of that. It was a good bit less than the edge count size. Hardware on there, man, I'm trying to remember. Usually the thing that drives, at least in my opinion, that drives the hardware factors are, I mean, part of it's going to be the size, of course, of the graph. But a big part of it will also be just like, what are you trying to do from a read and write standpoint? And so usually these things turn out to be very specific kind of tuning exercises on a per graph basis. So there's not like a really good rule of thumb that I would say for these things. Also, it's so dependent on the storage backend you use. Like if you use a ScyllaDB versus like a Cassandra, open source Cassandra or something like that. So unfortunately, there's not like an easy answer for that.
Awesome. Okay, well, if we did not get to your question, please feel free to respond to the email that I send out with the recording and all of the Q&As. Thank you, Ted, and all of our panelists for all of your hard work in presenting this valuable information to us. I know myself and many others were just eating it up, so we love searching your brains to see what we can find for all the new stuff coming up in JanusGraph. So I know we've got lots of people using it and enjoying it. I'll let you guys have the rest of your day back, and thank you for your time. Hope you'll have a great rest of your week.
Great. Thanks, everybody, and thanks, Ashley.
Thanks.